Pure, pasindi nga. Pasindi. Pasindi nga ito. Pasindi ito nga. Lobat ako.
Ano yan? Magdownload ka ng try mo i-download yung recording.
Hindi nga
So it's time to start.
Ay, wala pa lang, hindi pwede sa download dito.
Thank you all for attendance.
Ano yan?
Okay, so when I present my clinic, if you have any questions, raise your hand and you can open your mic and ask. So let's say would be like most questions so you can absorb most important information that you need. Okay, so I will share my screen. Good morning, good afternoon. Good morning.
Saan dito yung ano? Yung pwede yung pangalan?
Lobat.
Wala na. Hindi mo dito ang pangalan?
So we can start. So it's for A and A9. So I'm thinking that you all know or have basic anesthesia.
What problem?
So let's start with some basic anesthesia. What's the anesthesia machine and why
DC rooftop,
we are using it?
breaker, carbon.
So anyone can answer the question.
May mobile, may battery, may cellphone battery, lobat.
Wala kang mic eh.
No, oh yeah, I mean BTC, may cellphone, and lobat battery. Okay? God in charge, God in ever.
Why are we using the anesthesia machine? We are using the anesthesia machine to maintain the oxygenation of the patient during surgery. This is the most important point. Okay? And also, we don't want to consume all the gases that being used in the anesthesia process. Okay, so there is a recycling of the gas as well. Okay, so basically the anesthesia contains like analgesia and hypnotic, okay, or sleeping. So what's causing the sleeping to the patient is the anesthetic agent, okay, which is sevoflurane, isoflurane, desoflurane, okay. And what's causing the analgesia or removal of the pain is there's two ways, even through the intravenous or through the inhalation anesthesia. In the inhalation anesthesia, we are using the nitrous oxide, okay, to remove the pain from the patient. Okay. Third thing is the muscle relaxant. Muscle relaxant, someone confusing that the anesthesia machine will cause the muscle relaxant. No, the muscle relaxant will cause only by injection. Okay, so inhalation anesthesia will not cause muscle relaxant. Okay. So I think most of you should have this information, am I right? Or if you have any question, you can ask. No questions. I'm not hearing you guys. Okay, let's start with our project. So, this is A8A9 standard installation training. Okay, so I will present this content. Just a moment. Overview, installation, appearance, braking system, user interface, flow meter, vaporizer, ventilation monitoring, alarm management, previous system check, and maintenance. Okay, this is our anesthesia machine A9. How to recognize if it's A9 or A8? Actually, the main difference is only the vaporizer between A8 and A9. For the A8, we have the pneumatic vaporizer, while in the A9, we have the electronic vaporizer, or we call it EVA. Okay. Guys, are you hearing me?
Yes!
Yes.
You can continue.
So, in our right hand, we have the A8, and in the left hand, we have the A9, we recognize it by the vaporizer, as I told. This is the A8, which contains the P60 vaporizer, which been used in the A7, and the A5, in the Y2 series as well. And here the A9 with the electronic vaporizer. Okay, so in comparison with the competitor, this is the highest end anesthesia machine that we have. So we can compare the GES CS2 or Avance CS2. Okay, and for Draeger, we can compare it with the Zeus IE or Zeus family and Perseus as well. Okay, and the middle end we have 165, 55 Pro, and we have the AX65 and 55. We can compare it in GE with Care Station 65, 650, Care Station 620, and in the Draeger we can compare it with Arnan family. Okay, in the lower end we have 128, 35 and 30, and the EX20 and 10 also. We can compare it with GE devices, Care Station 30 for example, and Fabius Plus and Fabius Plus XL in Draeger. Okay, so what's the feature of our A9 and A8 anesthesia machine? So in A9 we have the 18.5 capacity. We have electronic mixer, electronic vaporizer as well, with the volume exchanger, the main feature of our high-end anesthesia machine. And we have this ventilation mode, we have the capability of plug-in modules, NMT, AG with O2, and PIS. Okay, and for the anesthesia feature, we have AA consumption, anesthetic agent consumption, optimizer, prediction, and automatic control anesthesia. We'll go through it one by one. And here, the ventilation assist feature that we have tidal volume according to the ideal weight.
Who was that, you know?
We have also the resistance, and we have also
Somebody opened the video. You know who was that?
Okay, and here we have some password, mandatory password for the user and for factory. I think most of you know it. For the user, for example, we can use 1234, or we can keep it empty if it's configured. Or for factory password, we have 789789. Okay, so this is the installation, preparation, installation, test after installation, acceptance, and open box failure. Okay, here we have, while we install the machine, we have to confirm that the gas supply is within the range. What's the range of the gas supply? It's from 200 kilopascal up to 650 or 600 kilopascal. From 2 bar up to 6 bar, or from PSI 29 to 87 PSI required. Okay, so we have to confirm that we have gas supply within the range of operation of our machine. Actually, our machine works from 2.88 up to 6 bar. Okay, which is 280 kilopascal up to 600 kilopascal. Okay, here we can have these samples. We can recognize for example, the diameter of tube from this number. Okay, and the standard of tube, if it's ISO, like I, and here what's the tube belong for oxygen or vacuum or nitrogen oxide. Okay, and here also we have if it's NIS or this, okay, or other standard. And here we have the tube length or the hose length of anesthesia machine. Okay, so by seeing this symbol, you can recognize for which gas is this one and what's the standard of this hose. Okay, we have many different standards. The most famous one is the British standard. As for example, in Saudi Arabia, most hospitals are using British standard.
Meron kang VIP ka account? Wala.
Okay, this is the tool that required during the installation process. Okay, and one more thing, for A8, A9, the battery will be installed from the manufacturer. So during the installation, no need to install the battery. Okay, we have lead-acid battery in A8 and A9. We don't have lithium battery like other anesthesia devices. Why? Because it consumes a lot of power. Okay. Also, the running time of the A9 by the battery should be around 90 minutes, okay? And we are using electrical vaporizer, which consume more power. And if replace the lead-acid battery with lithium battery, we need more than 4 batteries to work as the lead-acid battery. I think someone has a question or there is some noise in the background. Yes?
ज्वाइन किस पे आया ये लिंक किस पे आया किस पे लिंक किस पे आया
Huwag mo yan.
उसको आया
Pilipinin na.
I'm not hearing you.
Kaso hanggang 1 minute lang na-record niya.
Yes?
तो ये तो व्हाट्सएप पे दिया
Login to VI.
Okay, let's continue.
Isa marinig eh.
So, here when we receive the box, we have to check the tilt watch.
आपको कैसा लिंक
Okay, if there is the red mark,
मैंने
that
मंगाया उसको
means
आउटलुक पे
this box may be tilt. Okay, it's not mandatory, but we have to check it. Okay, and we have to check also the backing list. What's available accessories with the devices, what's the part included in this backing list. We have to confirm it. And also it's recommended to keep the backing after installing the machine, if possible, to keep the backing within the customer side for 3 days, just in case to confirm if there is anything missing. Okay? Okay, here how to remove the unit from the backing. Okay, remove the top paper card, remove the cardboard after removing the pipe side clip. Okay, then we can remove the machine. Okay, and here in the drawer we can have the accessories. In the middle drawer we have the HSS tube, for example, and other accessories. In the lower drawer we have the pipeline hoses. Okay, and here the boxes, suction, screen, and vaporizer. Okay. So, in here while we install the screen, the most important thing is to keep this loop during the installation of the screen. Okay, so you will just keep this loop connected to the main board, okay, and then fix it, okay, because if you didn't keep this loop while you are moving the screen up and down, the BFCS will be triggered and the EFCS will be, there will be an error with the EFCS and BFCS will trigger in case of emergency. It means that the signal lost from the screen. Okay, so mandatory we have
not
to
clear
keep.
no? Cannot be now it's clear
Mandatory we have to keep this loop.
Hold the table. Parang yung mic ko. Hold the mic.
Exit my screen, guys, and you come back. Just a moment.
Si Dodo. Is the one okay name?
your mic is on
My mic is on but I don't know why it's not.
call it make it off
Hmm?
otherwise your voice will be called
Oh, my voice. Because I have question now. I have asked.
Yeah. So mandatory we have to
Pero
keep this loop
question ka by
to avoid any error
Pwede ka
or
mag-type.
any sudden error during movement of the screens, which lead to pop up the BFCS, and the FCS will be faulty at the time. So just confirm that while you are installing the machine to keep this loop. Some of the anesthesia machine being installed on back, we found there's a problem with the length of this tube. So that's why there is a new part number for the tube with the exact length or with the recommended length to make this loop during the installation. Okay, this is what I'm talking about.
this loop
Okay, here we have the installation of the vaporizer. We have many filling system, quick fill, key fill. Okay, and Mindray only offer quick fill for sevoflurane. Okay, for sevoflurane we are offering the quick fill, and for the disofluran we have also we call it. We call it, we have the pour fill, we have quick fill, we have key fill, and we have safety fill. And for the disofluran, we call it safety fill. Okay, this is the standard. You'll see it. Okay, here the pour fill, how to fill. Just draw the bottle and you will fill your agent. Okay, and for the key fill, we have this key to fill the agent. And for the quick fill, the bottle itself has its own adapter, so you can just quick fill it to the vaporizer. Okay, so opening the package of the vaporizer, check the O-ring on the vaporizer manifold to avoid any leakage happen. Okay, so we have to confirm that there is an O-ring and it's installed properly. Okay, vaporizer put a wick inside. This wick will take 50 to 60 ml. So inside the pneumatic vaporizer we will have like some sponge. Okay, so for the first filling of the vaporizer, this sponge will absorb around 50 to 60 ml out of the anesthetic agent. Okay, so it's normal. If you are filling the vaporizer for the first time, okay, 60 or 50 to 60 ml will be absorbed by the sponge of the vaporizer. Okay, vaporizer lock system will look beside the vaporizer during opening. Same manifold, only allow one vaporizer open at a time. So we are not allowed to open the two vaporizer because of the manifold system. It will allow you only to open one vaporizer at a time. Okay, so here in the isoflurane we have safety fill, in the sevoflurane we have safety drill or safety fill with a quick fill also, and or we have other standard quick fill. So in the sevoflurane we have safety fill and a quick fill. In the tisoflurane we have safety fill. Okay, this is the standard. This is fill standard even in Draeger. Okay, so what's the difference between safety fill and safety fill? Okay, actually the diameter and the length of the adapter, the length of the adapter is different. So it's with a small length and bigger diameter. Okay, but for the vaporizer of sevoflurane, we have the safety fill or quick fill, which already integrated with the vaporizer bottle. Okay, and here we have we have to press the button to open the auto sensor. Yes? Please all close your mic if there is no question.
I'm sorry, that's actually, this certificate. So, if you need to go with friends, I think you need to pay. Yes, I got it.
Yung mic.
Okay.
Someone call you to my phone.
So here how to install the auto sensor. Okay, first we have to pinch two ear of auto sensor C, pull it out and install the auto sensor and then put it back. Okay. So here we have one feature or highlights of our A9. Recently it became also for the new 65 Pro as well. We have this feature HFNC. Okay, and for the A7 and the new A5 we have the HFNC, but it's optional. Okay. So watch this HFNC and what's the use of it. HFNC mainly they are using during the induction process, okay, to engage the oxygenation or the apnea of the patient during the induction process, especially for obese people. Okay, they are using the mask sometimes for induction process, but they found that there is a difficulty of breathing of this patient after some time. So that's why they are using the HFNC to elongate the apnea time for around 30 minutes. Okay, so it's more safe for the patient, especially during the induction process. Okay, so it's more helpful for the clinical during the induction process for the obese people or the person or the patient who has respiratory complication. Okay. So it's doing electron mixture of air and oxygen. With the oxygen, with pure oxygen, we can reach up to 60 liters per minute, while with the oxygen and air, we can reach up to 100 liters per minute. Okay? Built-in design to remove clutter and save space. It's built in the machine, so it's integrated with the machine if you have the HFNC option. So either you will have auxiliary air oxygen or you have HFNC. Okay, you have to use the humidifier, of course, to humidify the air which is going to the patient, or the gas which is going to the patient. Okay, and they are using the nasal cannula with the HFNC. Okay. Here the configurable plug-in module, we have like this, NMT, AG module, AGO2. Okay. The sample gas return, we have this feature, sample gas return. So in the old Watto or on the Watto series, we don't have this feature. Actually, the sample gas return in the Watto is connected to the AGSS. While in the A7, A9, we apply to A7, we go to the big system again. So let's say this AG module is sucking around 150 or for milliliter, for example, 120 milliliter per minute. Okay, so we are not wasting this 120. It will return back to the previous circuit. But for the old device,
All page
we are
3
wasting
copy.
it actually. Let's go to the AGS.
I will print one and then you make
Okay.
photocopy.
So to show the connection, you will hear a big sound when you insert the sample gas return tube. Okay. So while you are inserting it, at the end of the training, I will present some case sharing. So, for example, we will have some leakage because this sample line return was not plugged in correctly. So while you plug it in, you will hear a big sound. Okay. So here the anesthesia gas scavenging system, we have two types. We have the passive or active AGSS. Okay. So for the passive AGSS, actually we are throwing this hose to the exhaust room, for example. Okay. So we don't have like AGSS pump inside the device. Okay. In the A9 and A8, we have integrated AGSS, not similar to the Watto or to A5, A7. We were having the bottom of AGSS, low flow and high flow, but in our A9, A8, it's integrated AGSS. So the machine will be configured either in passive AGSS or active AGSS. Okay. So that passive AGSS only one type. The waste gas of the anesthesia machine is discharged outward through a pipe. The standard pipe company is around 4.5 meter and the connector cannot be installed on the wall. Okay, so if you have machine configured with the passive AGSS, you cannot connect this one to the wall. Otherwise, you will affect the pressure waveform of the device because this machine from the beginning is configured as a passive AGSS. Okay. Okay, and also we are not recommended to use hose more than of length more than 4.5 meters because there will be more resistance of the escaped gases, okay, and which will affect also the pressure waveform of the device. Guys, is it clear?
Yes, clear and loud and clear.
Yes.
Yes. Yes. Okay. So for the active AGSS, we have high flow and low flow. For the high flow, it's from 75 to 105 liters per minute, and for the low flow, from 25 to 50 liters per minute. Generally, low flow is widely used. This depends on the hospital AGSS system. The widely used one is the low flow one, which is from 25 to 50 liters per minute. And this number can be configured in the A9, can be configured in the service menu. Okay, so you can select the maximum flow range in the service menu, and then if you need to adjust it, you can adjust it from here. Okay. So this is the active AGSS, and this is connected also for the ACGO circuit to go to the AGSS as well. Okay, and here from this potentiometer we can adjust the AGSS flow. Okay, from here we connect the AGSS hose to the central AGSS system. If it's active AGSS, if it's passive, we need to connect it in there. We just connect the hose in here and then to the exhaust tube. We need to plug it down here because it's not active AGSS, so we don't have any pump. So if you are sucking it, it will affect the pressure waveform of the device. Okay, we have the two types of configuration of the suction, the integrated suction. By the way, this integrated suction cannot be upgradable. okay? Because it's integrated and there is a lot of tube connected to the backside of the device. That's why we are not recommend, or there is no FRU at all to upgrade it on the side. So it's a configuration of order from the beginning. Either you have integrated suction or no. Okay, so here is the pipeline section and this Venturi section. What's the Venturi principle? Do you know, guys? Anyone can share with me share with me what's the Venturi principle? Anyone of you? Yeah? Yes?
No different pressure because of the size.
Okay. Two different pressure?
Yeah.
More? Yeah?
Maybe it's not yet.
Okay. So this guy one, you are raising your hand. So let's say the Venturi pressure is like this, or the Venturi system.
Venturi is two sides. One is big, one is small. So
Yeah.
the size of the pressure on the size and the pressure in the small, you can calculate it.
Okay. So the Venturi principle, imagine that you have like high flow of oxygen or air or whatever. Yeah. Okay. This is a pipe. This is the pipe. Okay, and we have very high flow of gas from here. And in here, let's say I have small tube connector. Okay. So by the high flow from this gas or air or oxygen, it will suck whatever gas is here. So this is the Venturi principle. Is it clear? Is this clear, guys? Yeah?
Can you repeat it, please?
Yeah. If you have high flow of gas, okay, inside the pipe. This is the pipe, and you have very high flow of gas, okay, and you have another connector connected to this pipe from here.
Magiging vacuum yan.
So with the high flow of this gas,
Sa dental ko
it will suck whatever connected to this pipe. Is this clear?
Clear.
Okay.
Yes.
Yeah. Imagine that you are a smoker, okay, and you are smoking inside your car, okay, and you are opening the window while you are driving, okay, and your cigarette reaches to the window. All the smoke from your cigarette will go outside because of high flow. That's it. Is this clear?
I understand.
Yeah. So this is the Venturi concept. So they are using the air supply, okay, to suck from the patient, secretion from the patient, which is going to the suction button. So this one will be connected to the Venturi suction, okay, which is driven by air, okay, and all the secretion will go inside this button. This is the Venturi principle.
Venturi section.
So we have either Venturi section or we have pipeline section. Pipeline section, I will have vacuum connector of the wall supply. I just plug this vacuum connector beside my machine or behind my machine, okay? To suck secretion from the patient, which is going to the suction button. Okay, this is the installation way of the suction bottle. These bottles are connected together. Okay, because once this bottle is full, the other one will be also filling. And in the connection of the Venturi suction, we have this cap for protection. Okay, so whatever liquid will go to this cap to protect the Venturi suction from inside connector. Okay, the connection inside. So yeah, and actually, if there is any secretion going to this cap, it's recommended to empty all this suction bottles. Okay. This is the side rail configuration. You can find the part number of the side rail also in the part list, or we have also GCX part number related to the all the side rail that's supported by our unit. Usually we are dealing with the GCX for the arms of the monitor, for example, or the infusion pump. Okay, here we have the installation checklist. I will share it with you. Okay, and customer training is required. It's the part of installation. After training, confirm the customer is familiar with normal use process and daily maintenance. It's recommended that the customer keep the packing box for 3 months. It's not 3 days, even 3 months. But I think with the space of the hospital or sometimes they don't have warehouse.
How will we put this one?
Yeah, this is recommended. So in case if any missing accessories, you will refer to this packing.
Because if there
But
is
it's,
there is any issue, they can be returned back, huh?
To keep all these packing with them for 3 months. If it's a couple of days, yeah, it's convenient.
We have 40 boxes, don't do that.
Yeah, that's why. It's hard to convince the customer to do this. So that's why it's mandatory to check all the packing list, okay, and confirm nothing is missing. That's enough. Here? Okay. So, here is the acceptance and open box failure. Package broken, anesthesia machine service broken. Okay? So, at that time, you have to take a photos as a proof to us, okay? For the package and the anesthesia machine service as well. Surface, and then you have to create QE order on the CR. Okay? This is in case of broken surface of anesthesia machine or the package is broken. Okay, for accessories missing, compared with the packing list, you have the packing list paper or document. Okay, you will just compare all the available accessories with the existing one in the document or in the packing list. Okay, if there is any accessories missing, you have also to create CRN out of box failure. Okay, for missing accessories or missing parts. Okay, and you have to prove it by taking a photo of what's available package with you and what's mentioned in the packing list. Okay, if there is any function abnormality after the installation, and you make sure that you did all the connection and you check the gas supplies, it is with the recommended range, and then there is some abnormality of the machine, you have to take photo and you have to make the order also. Okay, as a out-of-box failure. We call all this problem as out-of-box failure. Okay. Then after creating the QA order, you have to fill in the questionnaire. Okay, so I will receive it as technical support, and we'll see, we'll confirm that there is some accessories missing, and send it to you, or whatever needed action from our side, we will do it. Here.
Yeah.
Okay, this is the appearance of the machine. We have 18.5. Sorry? Excuse me?
Narinig yan, ba't hindi niya pwedeng i-mute? Tayo ba narinig?
Yeah, okay, this is the appearance of the machine.
Akala niya kasi
We have
nag-question sila.
50.5-inch touch
Pero
screen,
pwede
and
niya
this
ma-mute.
gesture touch screen, our capacitive touch screen, which have gesture feature. So that means you can slide to the right, you will get a new window, and to the left as well, you will get a new window with the different waveform, for example. And also you can you can slide it down to discharge the patient, for example, similar to the patient monitor, okay, to the NCD's patient monitor, okay? We don't have any resistive touchscreen in the A9 or A8. It's only capacitive touchscreen, okay? And here the electronic flow control. Here we have the HFNC module or auxiliary air auto module, okay? Or auxiliary air auto supply, sorry. And here we have the integrated function. We have the breathing system or the breathing circuit. We have the CO2 canister. We have the CO2 canister. And we have the ACGO also. One working light, you know the screen. Okay? So this sometimes the anesthesiology call this table is a writing table. So they will just switch on the working light and they will write some patient information, for example, or patient history or whatever record they can write on this table. Okay? Here the electronic vaporizer, backup flow control system.
Sharon, mic test.
Okay? If there is a problem with the AFCS, automatically this door will open and the BFCS will work.
What?
Okay? We'll go to this side when we present the service training. Okay? This is the system switch. This is the gas supply gauge. Okay? The pressure indicator of the gas supply.
I just
and
sing one
here's
song.
the handle, the drawer, central brake system, and the foot rest.
You add it.
Okay, this is the device from behind,
Show.
or the rear view of the device. We have the auxiliary AC
कुछ
connector.
तो
We
किया
have
है
the main inlet or the main power connector.
यहाँ पे
Okay, and we have this hooks for cable management. We have the cylinder yokes, and we have the pipeline connector. Here we have the ground connector for example, this is the ground connector of the machine, and if you are going to make the safety test, for example, so you connect to the ground port here. Here we have the communication port, VGA, and also the USB connector. We have the hooks, we have the overfill protection cap for the venturi suction or for the suction if it's a vacuum pipeline suction. And here we have the waste gas or scavenging connector. We have the liquid collection button for the suction. Okay, here this is the mount for the GCX. For the GCX arm, let's say, and here this is the HFNC outlet. So this HFNC outlet will be connected to the humidifier. Okay, and then it will go to the patient nasal cannula. Okay, to the patient. Here is the hook for the tube of the HFNC mainly. And also here the module, the HGSS flow control knob. So we are setting the highest flow at the service menu, and then we can control it from here. Okay, and depending on the hospital flow of the HGSS. So if the hospital is higher than our machine or lower than our machine, we can adjust it to suit the range of the hospital. Okay. Here is the sample gas return, and here is the high pressure outlet. What's the high pressure auto outlet? Sometimes there is another peripheral device need to be connected beside our machine. So in here, it can give me similar output of the gas supply, of the wall gas supply. So it's like extension from the wall gas supply. So, and by we will connect one hose to the other devices. Whatever device, what's peripheral device need gas supply or need oxygen supply can be connected by the hose to this outlet. Okay, is it clear? Sorry? Yeah, if you are connected also a flow meter, for example, you can just put the flow meter at the side rail and connect the hose from here. Okay. Here, the monitor or the display of the device, we have the button for the working light switch. Okay, and we have the working light. We have the GCX rail for monitor arm, let's say, and we have the handle outside rail, and we have also other mounting rail. Okay, this is the drawer, and we can up and down limit for the drawer to avoid any blocking. So the upper limit is 45, and from upper and down limit from 15 to 45 degree. Move out of range might cause damage of the drawers. Okay, and this is also the monitor of the device. It's also rotatable, and you can move it up and down as well. This is the working light, and this is the working table as per the necessary. Okay, this is how you connect HFNC to the humidifier and then to the nasal cannula to the patient. Okay, we have multiple connectivity issues to the side layer of the device. Like for example, if we are connected the NCD special monitor and we are using, for example, IVU screen can be inserted here, or if they are using also independent screen, they can put it here as well. Is it clear?
Loud.
Where do you use the humidifier?
The humidifier?
Yeah.
It's mandatory to be used in the HFNC, in the high flow nasal cannula, because you are getting here. If you want to get 60 liter per minute of oxygen flow, you can use the pure oxygen to get 60 liter. If you mix it with the air, you are able to reach up to 100 liter per minute. Okay, and this is actually it's dry gases, so you have to humidify it. That's why you are using the humidifier.
Okay.
Okay, here the breathing system. Classic breathing circuit, panel designed with ABL, auto manual switch, pressure gauge, inspiration, expiration, unidirectional valve, and pre-pack CO2 canister. Okay. Heating for whole breathing system, the clear indicator illumination of ABL to indicate the manual mode, ABL quick release. Okay, so what's the difference between the heating system of the A9 and the A7, let's say?
Humidifier?
Do you know any difference?
Can you come again?
What's the difference between the breathing system of A9 and A7, let's say?
Wala kasing bill. Wala
Do you have A9?
In the A9 there is a volume exchanger, and in the A7 there is below.
Yeah, this is the ventilator. Okay, for the breathing system, maybe, if you are going to make like the leakage test of your A7, okay, you have to make the auto and then switch it to manual to make the manual leakage test as well. In the A9, we have micro switch inside, so no need to switch from auto to manual. It's automatically detected. So the machine will go to do the auto leakage test, and then by itself it will go to do the manual leakage test. So no need to switch from manual to auto during the leakage test. Okay, and about the illumination of the ABL, here is the illumination in the blue color. Okay, and about the quick release. Okay, so if you need to release the bag pressure, you will just pull up the ABL valve. This is the quick release feature. Is it clear? Guys, what's the pre-pack CO2
Yes,
canister?
it's clear.
What's the benefit from the pre-pack CO2 canister? We have also disposable CO2 canister. So pre-pack, that means it's already packed before. Okay, so we just remove the packing and install this canister. This is the pre-pack feature. Okay. So, do you know what's the bypass assembly?
Nobody don't.
Okay. What's the question? What's the bypass assembly of the canister?
Bypass. During the previous
If you
check,
remove the canister,
previous check, diba?
if you remove the canister, the circuit is still closed.
Yeah, that's right. Yeah. So the bypass assembly is that it's the feature that enables the doctor to change the solder line during the surgery without leakage. Okay, the circuit will still remove this. Okay, so this is the absorbent and compatible with loose fill and the pre-pack absorbent. We have two types of this canister, loose fill or pre-pack. Okay, and quick remove the absorbent and condensate water at the same time without tool. So no need for any tool to remove the canister. You will just switch off the handle and remove the canister. Replacement of absorbent is allowed during the surgery CO2 bypass because we have the bypass assembly here. So bypass allow the doctor to remove or to change the soda line or to refill the soda line during the surgery without leakage. Okay.
What's the, excuse me, what is the difference between loose fill and pre-pack?
Loose fill and pre-pack. Actually, the pre-pack, that means it's disposable soda line canister. Okay. We call it pre-pack because suppose this canister will come back already and you just remove the bag and install the canister. There is the part number of accessories for the pre-pack soda line canister. Okay.
So in the picture, it is pre-pack or loose fill in the picture?
Also, they call this one pre-pack, but actually pre-pack will come without this handle. Okay. It's only the canister bag. You will just remove the bag and install it. Loose fill for the old devices also. They have like a canister. It's not pre-pack. Okay. That's the one which we call it loose fill. It's different shape, by the way. It's not similar to this one. So this one also they are calling it pre-pack. It's different shape, similar to the Wato or to the A7, the old one. This is the loose fill. But
okay, I knew it.
Yes, very rare you will find this configuration with the A9. Mainly A9 will come with from the manufacturer with the pre-pack set or with the bypass assembly set as well. Here?
Loud and clear.
Yes, clear.
Okay. So here the most important feature of our A9 or A8 as well, we have the volume exchanger. So what's the benefit from the volume exchanger? This replaced the pillows.
Yes.
Okay. So what's the benefit? Quick wash in and wash out by small system volume and precise ventilation for all the patients from adult to neonate with tidal volume down started from 5 ml and 0 p. You know, in all anesthesia or in the pillows anesthesia, it's impossible to reach the 0 p. Why? Because the pillows will not go to the base. There will be some rudder, okay, and it has some pressure. Is this clear?
Yeah, because there is some.
Yes.
Yeah, so you will never reach 0 p with the pillows anesthesia,
Yes.
even GE.
All anesthesia, I think.
Yeah, so this is an important feature of the volume exchange that we can reach the 0 p. And the tidal volume started from 5 ml, showing the state of breathing system clearly by visual volume exchanger indicator. This is the one in the administrator screen. We call this one administrator screen. Okay, so it will show the inspiration phase as well the expiration phase. More reliable and less risk of malfunction with no moving component, providing extremely reliable and greater service life.
It's like quick wash.
Quick wash and what?
This is okay.
Yes. Available this one.
What do you
No,
mean
no,
by
no.
quick wash?
No, washing out of the gases.
Okay.
Washing out of the gases. For example, if you want to wash out the volume exchanger, you will press the auto flush and it's easily washing out because there is no many component inside. It's not like the pillows. This is the meaning of wash out. Okay? Uninterrupted ventilation when excessive leakage.
Why do we need 0 p?
It depends on the patient situation. Sometimes the doctor decides to make zero beat for the patient.
Or neonatal.
Or for neonatal. Yeah, it depends on the patient situation. So it's a clinical feature.
Physiologically, zero peak is like a gaze patient, yeah?
Sorry? No? No. Dasho, you hear about the intrinsic beep?
Yeah.
The intrinsic beep for obese people. For example, some portion of the lung, due to the obesity of this patient, okay, it's closed and it has some pressure inside. So this is intrinsic beep. In this case, the doctor will try to minimize this intrinsic beep. So at that time, maybe the doctor decides to put zero beep because the patient already has built-in beep, cannot be released from the lung. It is clear. And sometimes for ARDS patients, for critical situations, the patient, the doctor decide to put zero beep. Is this clear? Or for neonatal patient as well?
Okay.
So it depends of the dietary complication or the situation of the patient. The doctor decide to put zero beep. Okay. And uninterrupted ventilation when excessive leakage happens. You know the pillows that have, if it has excessive leakage, more than 200 mm, okay, the pillows will go down and it will not raise up anymore. Okay, and you will receive a lot of complaint from the customer that this pillows goes down, there is a problem, and actually it's only leakage happened during the surgery. Okay, so since this device has not has no movable part, okay, and it's only gases flowing in this volume exchanger. So even if there is excessive leakage, I already have my gas, okay, I will consume a lot of gases, but at the end, I will not stop the surgery because of the leakage, similar to the water or to the acid. Is this clear?
Yeah, very much precise.
Yes.
So if there emergency leak, the machine will work normally?
Yeah, it will work normally, but it depends also what do you mean by huge leakage? Like for example, if the leakage is 1 liter, even with the flow of gases, I cannot compensate this leakage. But for leakage, if it happens more than 200, like let's say 400, yeah, they can continue the surgery with this. Okay, they will consume more gases, but they will not interrupt the surgery. Okay. So this is the pneumatic diagram of the volume exchanger. I prefer to let you see the video that I have to describe this more easy for you. Are you seeing my screen, guys, or it's only the presentation?
Presentation.
No.
Presentation.
Okay.
Another presentation.
Just a moment. So now you are seeing the video now?
Yes.
Yes.
No sound.
Just a moment. Hold on a second. Now we are seeing the king, guys. I'm sorry for this interruption.
Yes, yes. No problem.
Are you hearing the sound as well or no?
Still no sound.
No sound.
No sound. No sound.
No.
Maybe he got money close.
No sound. Share audio yan. Share audio. Yan ang may siniset up niya. Share audio lang.
Okay.
Pero tayo hindi tayo naririnig doon, no? Sa live tayo naririnig.
Even now, no sound at all.
Yes, no sound.
Inspiration.
What is this driving gas? Oxygen or air?
Yeah, it's oxygen. Okay. It's oxygen, and it's actually, if there is a problem with the oxygen, or the oxygen is going below 125 kilopascal, okay, it will automatically switch to the air.
Air. Okay.
Yeah. Sorry, I will solve the sound problem later, but you can see the video to see the relation presented like this. Yeah.
Do explain while the video is.
Yeah. Okay.
Ah, Mr. Swan is there.
So this is the one who plays the bell one.
Yeah. See, this is the driving gas. Okay, in the green. And this is the expired gas from the patient. Okay.
Why two line, not only one? One inspired, one expired?
No, it's not one expired and one inspired. For more efficient, that's only because, for example, do you know McKay flow eye anesthesia machine?
No.
McKay flow eye having the similar concept but with one layer only. So they found that 2 layer is more efficient. So they designed it with 2 layer.
Okay.
Okay.
So you mean the press gas and the inspiratory of patient are mixing together?
Mixing together with the dry gas, no?
No, I mean the press gas, the one with anesthetic agent and the breathing patient are mixing there.
It's not mixing because while the patient exhale,
Expiratory naman yun.
Yeah.
this blue is expired gas from the patient. Okay. So again, for the inspiration, it will pass to the soda lime canister and absorb the CO2 and then go to the patient again.
I'll go to patient again. Okay. Yeah.
Yeah. So the exhaled gas will go to the volume exchanger. Okay, and in the next inspiration phase, again the dry gas will push this exhaled gas plus some more gases from the mixer, of course. Okay, and then it will go to the canister to absorb the CO2 from it, and then again will go to the patient. Is it clear?
Yes.
Okay. So someone will ask, is the dry gas will mix with the gases of the patient or with the fresh gas flow?
Yeah.
Here, less diffusion due to smaller contact area. So there is no enough contact area between these gases to mix up together. So this is smart design. So they calculate the diameter and the interaction between these 2 gases. So these 2 gases are not able to mix with each other. Okay, as you know, the pillows, the dry gas will be the upper side of the pillow. Yeah, outside.
Yes.
Yeah, outside the pillow. So for sure, because there is a diaphragm, it will not mix with the fresh gas.
Press gas. Yeah.
Yeah, and here also they calculate the spaces which will prevent the mixing of the dry gas to the fresh gas.
Okay. So you mean the driving gas is the green one and the blue one
Yeah.
is the fresh gas?
Exactly. Yes. Yes.
Okay.
Yan na yung bilos niya. Yung gas exchanger. Wala nang bilos yan eh. Gas exchanger.
Excuse me, but as we see in the video, there is no contact between the drive and the fresh gas pump.
How come?
It should be mixed. It should be mixed.
No.
Yeah.
There is
So
a
this diffusion. Yeah. There is no space. There is no any diaphragm between both of them. But here you can see this diffusion due to smaller contact area between two gases. Yeah. So the dry gas will not mix up with the fresh gas.
Now, in case of leak, is there anything happen that dry gas will go to the patient lungs because of the leak?
Oh.
Because of the leak, the machine will try to compensate, okay, but you're still monitoring both gases, which going and come back from the patient. And also we have in the A9, A8, we have the internal gas module. It's mandatory to be there in the A9. Okay, so we have two ways of analysis of the gases, the internal one and the external one as well, the external gas module. Okay, so in case of leakage, yeah, it might, for the leakage compensation, there will be more oxygenation because the dry gas at the end is oxygen. Okay, but all of these will be monitored by the gas module. So the user will be aware about this, and also in case of leakage, in the administrator screen, it will give an indication that there is a leakage, that the machine is compensating a lot.
Okay.
Yeah, so the user will be aware as well.
Very nice design.
Yeah. So let's see the inspiration phase and the expiration phase. Here, this is the non-return valve. Inspiratory non-return valve. Okay, and here is the expiratory non-return valve.
Yeah. Where is the auto plus?
The auto flush.
Yeah. Oxygen flush.
Yeah, there is in the front of the table. There is auto flush.
But not connected in the diagram.
In the diagram here? No, I will
Yeah.
show it to you in the block diagram later on the service.
Okay.
We will show it, yeah.
Auto mode.
Okay, so what will happen in the expiratory phase? So during the expiration, the machine will let the patient to exhalate, okay, until reaching the peak limit. Okay, so the expiratory valve will be closed or will be open at the peak limit. Okay, whatever exceeded the peak limit will go to the AJSS.
Okay.
Got it? And in the inspiration phase, the expiratory valve also will be closed at the bow limit, the airway pressure, which is, let's say, 40 millibar or 50 millibar. Okay? So the expiratory valve in the inspiration phase will be closed. And the pressure limit of that one is whatever the doctor says the bow limit. Okay, so in case the doctor said, let's say, bow limit is 50 or 40, Okay, so once there is more pressure than 40, for safety, the expiratory valve will release this pressure to the HA space to avoid over-pressurize the patient.
Actually, he's busy in the meeting. Anything?
Is this clear? It will be more clear when we demonstrate the block diagram.
Yeah.
Yeah, it's very good.
Why your APL valve is in the expiratory side?
The ABL valve in the expiratory side.
Yeah, for the valve.
No, it's located there, but actually it's not in the expiratory side. Okay. Of course, what's the APL valve? It's adjusted pressure limitation, right?
Yes.
Yeah.
Or a manual.
Yeah, so I'm adjusting the pressure of the manual bag. Okay, I will not. Yeah, if I increase the pressure than the adjusted or than the limit, this exceeded pressure will be released to the HA space as well.
Okay.
Okay. So let's say I adjusted to 30 millibar, let's say, and I pressed of more than 30 millibar.
Yeah.
The exceeded pressure will be released to the HA space.
Okay.
Okay.
This is manual.
Yeah, manual mode. Still the manual mode is passing to Anesthesia.
Yeah, for sure, because what's the difference between the manual and automatic mode? The manual detectors ventilation the patient manually. Okay, so for sure I have CO2 exhaled from the patient. That's why I need to pass by again to the CO2 canister to absorb the exhaled CO2.
Yes.
And if you see, this is the ABL limit. So this bag will inflate up to reaching the ABL limit.
Yes, up to 30.
Okay. Yes, up to 30, for example, whatever ABL limit. Okay. Whatever exceeded pressure than the 30 millibar will be released to the HA space.
Okay. Very nice design.
Yeah, see? So this is the administrator screen of the device. It will give you a clear or correct indication of the tidal volume delivered to the patient. See, if there is a leakage, here the administrator screen will indicate the leakage. So the doctor will be aware that there is some leakage problem and they will try to fix the tubing or whatever, but they will continue the surgery. But this indication that the machine will consume more gases to compensate this leakage. It will come exactly like this in the administrator screen. Clear?
Kina-compensate kasi.
Yes.
Kailan tataas yung value ng tataas yung gas consume. Yun ang nun. Okay.
So it's this risk of malfunction with no moving components, like the pillow. The pillow, you have the pillows, and you have the pillow's cover, and you have the O-ring below the pillow, and you have the pop-up valve, all these stuff. But here, there is no movable component. You will just unplug this one and send it, for example, to the sterilization or to the autoclave.
Yan yung gas exchanger.
Plasma.
Yeah, to the plasma even.
So the volume exchanger is autoclavable?
Autoclavable, yes.
134.
But to be honest, I'm not recommending to send it to the autoclave. If there is a way to sterilize it, it's much better. But it's autoclinical, yeah.
Plasma is better than.
Yeah, you have to mention the temperature.
134, you will see it later on.
Okay.
So is that clear?
Loud and
Yes.
clear.
Yes, yes.
Yes. Pasang ako sa talan dito. Inaano lang to. May mics na sila. Ah, may mics sila. May mic na tayo. Detective pa to.
So guys, do you need any break for 10 minutes, like 10 minute break?
Yeah, coffee break.
Okay.
Okay, copy.
Yeah, so we need break.
Lunch break.
Yeah, so now it's 11:15, so we'll return at 11:30, it's okay?
Yeah, it's okay.
I think it's better to make it for after 10 minutes, so we will go to pray.
Okay.
And
So we'll extend for 10 more minutes and then we'll have a break. Is it fine, guys?
Okay.
Yeah, it's fine.
It's better.
Yalla.
It's fine.
It's fine.
Okay.
Okay. Yalla.
So the user interface, bigger size, more information can be displayed, high resolution, more detail can be clearly, dual operation principle, capacity green or not. Okay. So if you want to adjust any parameter here, you will just press this parameter. Yes, tell me.
We don't see the presentation.
Just a moment.
before you said, when you said there is a train from Mindray, you said 2 or something.
Sorry? Sorry? Now you are seeing the screen, right?
Yes.
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 Okay.
Oh, your mic is not working.
So we have bigger size, more information can be displayed, high resolution, more operation principle, capacity, touch screen or rotary knob. So any parameter you want to adjust, you will just press it. The machine will give you a choice to increase the parameter or to set the value, or otherwise you will just adjust it by the rotary knob. Okay, rotary.
خلاص؟
Nag-10 ka tayo. Hindi.
Continue.
Wala.
You click somewhere.
Wah! Sana. Ano nangyari? Back.
Gesture touch screen, slide, drag, from mobile user interface element, keyboard, slider, and the button. So if you select, like for example, the title volume and you want to adjust it, you will just put the new number, new title volume, and you will just confirm it. Or otherwise, you can just select it and adjust it by the rotary knob.
Disconnect my internet.
So there is a multi-way to adjust. Okay. So innovative interface feels similar like mobile phone, extremely simple to learn, graphical instruction. So in case there is like for example now airway pressure too high, directly the machine will give you a graphical interface to check like there is any problem with the tubing or is there any tube like compressed or something. So it will give you indicator to check your tubing because I have very high pressure. Okay. Intelligent layout to provide maximum content without overlapping the critical information. Okay, here we have here is the patient information. Number 2 is multi-gas monitoring, the oxygen, nitrous oxide, the anesthetic agent or MAC. Okay, and number 3 is the countdown of the surgery. Like if they will start counting. Then current ventilation mode. Number 5 is the waveform pattern and parameter also. And also number 6 is the alarm message. Number 7 is the number of active alarm. For example, if there is a high priority alarm, it will not be in as a catch alarm. It will pop up in red color here. So, and for the old alarm, you are able to see it. If you press number 3 here, you will see the old alarm window. Okay. Here, for example, number 11 to adjust the volume, number 12 to for the sitting menu, for the user menu, and if you want to go to the service, but once you go to the service menu, it will exit the operation. Okay. Number 15, for example, the power supply status, the ventilation setting. Number 16, fresh gas and vaporizer control. Number 17. Okay. So in here you can, while you are on standby and the doctor is going to start the surgery, they can select the patient type. Okay. In the standby, and they can, for example, they can put the height, the weight of the patient, the age, and gender as well, ideal body weight to calculate the parameter based on the ideal body weight. Okay. Decide the default tidal volume and the frequency, calculate the ideal body weight, the tidal volume depend on the ideal body weight. All these settings before the surgery, the doctor can do it. Okay. Decide the default value of manual of minute ventilation in the AMV mode. This AMV mode is like intelligent mode. So the doctor will just put the target minute ventilation, okay, along with the beep, and then the machine will work like autopilot for the ventilation parameter to reach this targeted minute volume. Okay. Here is the equation to calculate the tidal volume, or to calculate your ideal body weight from the height. Okay, so either you have two options, or the doctor having two options. To insert the patient height, then the device will calculate his ideal body weight, or directly he can insert the ideal body weight of the patient. Accordingly, the parameter will be calculated depending on the set ideal body weight. Okay, we have up to 5 waveform. Okay, can be seen here, and customize the number and content. If you press the waveform, you will just choose which waveform you want to see. Okay, and we have the mini trend window. We have also the loop window. I think all these are clinical parameters or clinical topics, but we should be able to present it to the doctors as well, at least. Okay, up to 5 waveform at the same page, customized number and content, mini trend. Okay, function slide left or right to see more information. This is because of the gesture touch screen. Okay, here's the loop, and here's the anesthetic agent prediction. For example, if you run the prediction, here is it. Here is it. The prediction. What's the prediction? The prediction is if anyone have worked before or know about Draeger, they have feature called Smart Pilot. The Smart Pilot of Draeger is the prediction in Mindray. So, what's the meaning of prediction? Prediction, that's mean the machine will predict the behavior of the anesthetic agent, of this patient, anesthetic agent and oxygen in next 20 minutes, depend on the last 10 minutes. Okay? So the doctor will be fully aware about the status of the patient. If the doctor decides to decrease like the anesthetic agent concentration because of the prediction, predict that if you still in this anesthetic agent concentration, the patient might go to deeply coma, for example. So the doctor will be fully aware about the behavior of the patient after 20 minutes, and the machine calculate the next 20 minutes based on the last 10 minutes. So it's intelligent feature. It will guide the doctor to adjust the anesthetic agent and oxygen concentration, okay, or keep it as it is, depend on what's the prediction of the next 20 minutes. Is that clear?
So it's predict the mark of the patient?
Yeah, you are right. It predict the MAC of the patient with the oxygen concentration as well. You know what's the MAC, right?
Minimum alcohol concentration.
Yeah, minimum alcohol concentration of the anesthetic agent. So it will predict it. Similar to the autopilot in other competitor company. We have the prediction. So based on the last 10 minutes, the machine will predict the anesthetic agent concentration in the next upcoming 20 minutes. Or the next in the upcoming 20 minutes.
You said it predicts oxygen concentration, but if we connect the machine on the only auto source, it will be always 100 concentration. Oxygen.
Sorry?
You said it predicts auto concentration.
Yes, it predicts the auto concentration and
but if we connect the machine only to auto source pipeline, it will only 100 concentration.
Yeah, but usually you are connecting the oxygen with the carrier gas or with the balance gas, which is air or nitrogen. Yeah.
Okay, I got
So it's not 100%. By the way, rarely, very rare, they are using 100% of oxygen for the very short surgery or very short time surgery, because the 100% of oxygen for a long time, it might lead to brain death. So that's why, or if the doctor decides to use the 100% of oxygen, he will use it for very short time.
In Iraq, in all surgery, they use 100 oxygen. In all surgery.
All surgery?
Yes.
For how long do they surgery?
Sometimes 3 hours, 4 hours.
With the 100% oxygen?
Yes. They connect the machine only to auto source.
I don't know if there is any medication needed or something, because as I know, it's really dangerous for long time of oxygen, of 100% of oxygen. Yeah, it's very dangerous. And even when I was in the HQ, I saw old water configured with oxygen pipeline only. So I was asking at that time, so there is no other choice to give more, less than 100% of oxygen. They said, yes, but this is for very short surgery. So that's why it's not recommended to connect the patient with 100% of oxygen. I don't know if they are giving him some drugs or something. I'm not sure. Yes. So we have also up to 2 loop at the same page. Waveform and loop can display at the same time. Okay, so we have the waveform and we have the loop, and also we have reference loop. So once the doctor sees that this loop is optimal loop, he can select it as a reference loop. Okay. Maximum save 1 baseline loop and 5 reference. Okay. Here display the prediction curve and history curve of the anesthetic agent concentration and auto concentration as well. Okay. So if you see this is the MAC, and here's the oxygen concentration as well. So there will be one waveform or one graph for the MAC and the other one for the auto concentration. This is the prediction. Okay. By the way, this prediction have been also used in the new A5 and new A7, and some old A7 having this prediction as well. But mandatory to have the prediction, you should have the internal AG module. Okay, not only the external. So without internal AG module, I cannot work in prediction. Here?
Yes, please.
Loud and clear.
Okay, so the function is a history for 10 minutes with a black background, and the prediction will be 20 minutes with the gray background. clinical benefit, better projection of future state based on the trend vector for agent concentration, better perception of the current state of the drug delivery, drug concentration, and even predict drug concentration. Better adjustment of paper setting to individual patient needs. Okay, how to set a quick key? A quick key, we have a quick key feature also from the menu system, and this, the code will be 1234. Set up a quick key. Okay. So here is the quick key setting. Like you will add it, this key will be fixed in the display for doctor usage, for example. If the doctor will use the flow pose, for example, so he need to set up during all the surgery to be as a quick key instead of going to that flow pose. You just turn on this flow pose from the quick key menu.
Hello,
and it will be fixed in the display.
Yes, sir.
Okay, this is the trend and not to type this trend and graphic trend. Length for 48 hours. We have the trend for 48 hours registered in the device. Okay, and we have the list trend and the graphic trend. The list trend, I mean, every 1 minute there will be a new trend. Okay, so that's why if there is a problem happening with the device, and we are caring about the trend view. Okay, so I'm telling you, please export the log as soon as possible. Don't exceed the 48 hours to see the trend view. Is that clear?
Yes, clear.
Yeah, and for the event log, we have up to 10,000 record in the event log. Okay, you can reserve it, or otherwise, also if you are exporting the service log, we'll have all these event record. It's much important for us to analyze the problem. Okay, and about the screenshot, you can save up to 50 screenshots. Okay, you just press the screenshot button and the machine are able to save up to 50 screenshots. Once you insert the flash disk, you can export all these screenshots to the flash disk. In case of research or in case of medical investigation, for example. Okay, and also you can export the history by USB. You will just select the USB mark and then export the history to the USB. But usually for analysis from the service side, we will ask you to export the service log. We'll see it later on. Okay, here is the setting for the patient profile. We are able to set up to 10 profile. So what does it mean? That means, for example, the doctor is doing on the same machine some neurosurgery, some other surgeries, some OB-GYNs in the same machine. So he has decided profile for each surgery type, for example. He is able to save up to 10 profiles. You just select the profile needed for the specific surgery. Is that clear?
Kalau shitty yung flight-nya, waiting for visa and ikaw ba? Ha?
So let's have a date for 15 minutes.
Shitty yung flight-nya. Waiting for visa and ikaw.
Okay.
Mangyayari pa pa yun. Saan ba yan, man?
So see you guys after 15 minutes.
Dinilinggoy lang to eh.
15
Online,
minutes.
wala pa yan. Yung
Yes.
kailangan nila i-renew yung ikama para makuha yung visa. Yung ikama, mabilis lang din yun. Kaya pala. Lubat pala. isang team mo. Yung iba na nasa isang
AGSS, okay, on the AGSS limit, or it has to be between the minimum and maximum. Otherwise, you can adjust it from the potentiometer in the device. And here we can see the pressure of all connected gases with the cylinder as well. So this is the administrator screen. This is non-touchable and non-configured as well. This is by default will be like this. Okay, so this is the touchable screen, and this one is only default screen. These are the parameters that can be seen in the administrator screen. Okay, indicate auto mode and manual mode as well. Indicate breathing pattern, inspiration and expiration. Indicate the real tidal volume delivered into the patient lung with the compensation as well. The scale of the circle adapt to current monitoring value automatically, making the observation tidal volume more clear compared with the pillows, especially when the tidal volume is very small. Okay, breathing system status for indicate the abnormal status of breathing system. Example, excessive leakage. So if there is a leakage, it will indicate there is a leak. And if there is discontinued also, disconnected, it will indicate the disconnected. How detect that there is disconnected? Because it will inspire the patient, but there is no expiration pattern came to the device. So it will detect as disconnected. Clear? Gas supply status and the vaporizer also. And also it will indicate the agent type, CIVO or ISO or DISO. If there is a vaporizer failure, also it will be indicated. It will be indicated in the administrator screen. And here is the limit of the AGSS. If it exceeds the limit or if need to be adjusted, normally it should be like this. Okay, and we can also disable the AGSS alarm. From the alarm limit, we can just disable this alarm of the AGSS. Okay, this is the flow meter, electronic flow meter, electronic display and electronic control, easier, safer and more precise. Free adjustment method, so either by the knob, okay, or the via touch screen and the numeric number, or a quick set. Quick set, the doctor can, by default there is a quick set, but the doctor can change it also. The quick set default flow rate is 1, 2, 5, 10 liter per minute, will appear here. Okay, and the doctor can customize it as well in the profile. And when the doctor make his own profile, he can customize this preset flow rate. So there is 3 ways of adjustment, via the knob or via touch screen or via the quick set, which already customized by the doctor when he make his own profile. This is the same for the quick set flow meter for shortcut of flow rate. The default setting 1, 2, 5, 10 can be customized as saved as profile. Okay, this is the optimizer. What's the optimizer? Optimizer, we have it also in the old anesthesia machine. We have it in the Wato 65 Pro. We have it in the A7 as well. So anyone knows what's the optimizer? Okay, indicate the optimal fresh gas flow rate. Now the goal of the doctor is to reach the minimal flow rate, fresh gas flow rate, okay? Because it's easier for the patient to breathe, Okay, decrease the work of breathing from the patient side, as well less consumption of gases. So their goal is to decrease the fresh gas flow as much as possible, and this optimizer feature will let them know the sufficient fresh gas flow for each patient. Like for here, the sufficient fresh gas flow should be in the green area, or the optimal fresh gas flow. For example, here it's high, and here is the efficient, and here is the low. So the doctor will adjust the concentration of the fresh gas flow accordingly to meet the optimal range, or to meet the efficient range. Mandatory, we should have the aging module in the device, not the internal one. The external one is enough for the optimization, but for the optimizer. But for the prediction, we should have the internal aging module. And for A9, it's by default there is internal aging module. It's not a configurable item, or it's not upgradable. And by default, it will be there. Is that clear?
Yes.
Okay. Backup flow control system. In case if the electronic flow control system, or let's say the mixer, fail, directly this door will be open, okay, and the backup flow system will be running. So the doctor are able to adjust the oxygen flow and the carrier gas flow, or the balance gas flow from this potentiometer, and he can continue in the PFCS mode. Okay, PFCS provide O2 and air mixed gases. Even if he tried to minimize the oxygen flow to the minimum, there will be a basic flow for safety, which is 1 liter per minute of oxygen. Okay, so the total flow rate from 1 to 10 liter per minute. Even if the oxygen is completely switched off by the potentiometer, there will be base flow of oxygen for safety, because now I'm in the backup mode. The main mixer, or the electronic flow control system, faulty. So now I'm working in the backup mode, and in the backup mode there is a baseline oxygen flow which is 1 liter per minute by default for safety. Okay, the vaporizer. We have 3 agents: ISO, C1, GISO. Electron control vaporizer, injection principle. We will go to it during the service, or in the block diagram also. Classic position is to remove and refilling. Handle for is remove and restoring. Calibration free and maintenance free. So in case if you have problem with your vaporizer, okay, there is option to calibrate the injector only, and to check the drive gas pressure regulator of the vaporizer. Otherwise, you have to replace the complete vaporizer unit. It's non-repairable. You are not assembling it, and you are not allowed to disassemble it and assemble again. So in case if you have problem with your electronic vaporizer, you will just replace it with a new one. Clear? Okay, Mindray V90 electronic vaporizer, three-way adjustment via the knob, or via touch screen, or via touch screen, press the target value around the virtual dial. Okay, here's the purge flow. What's the purge flow? Purge flow used to flush out the vaporizer. You can decide your purge flow. So the purge will turn the vaporizer off, flush the agent based on the purge flow rate stated here. Clear? For example, after the surgery, the doctor decide to flush out all the anesthetic agent from the vaporizer. He will set the purge flow, and he will just press purge to flush out, to wash out all the gases inside the vaporizer. Clear? Mindray V90 electronic vaporizer purge, quick wash out the agent from the breathing circuit with preset high flow rate fresh gas. Speed up the recovery phases. Okay, so During the recovery, mainly the doctor will increase the oxygen concentration, sometime up to 100. Okay, and he will do the purge of the vaporizer to wash out all the gases. So this will expedite the patient recovery phase. Okay.
Question.
Yes.
When the doctor select the purge, the vaporizer will be off and there is no agent in the circuit.
All the agent will be washed out by the purge. Usually they will select this purge while they want to shift from the maintenance to.
Ganda ba yun? Rubber tape. Ano ba itong brand nito? Malas. Wala na. Okay ba ito?
Okay.
Pwede na. Rally to sa inyo.
Tara ako, sir.
Pwede na?
Oh.
Wala yung sound ko.
There will be comparison between each measurement, the internal one and the external one. Okay, and the machine itself will adjust the parameter. Okay, so the machine will work just by itself. machine will knock off that exit from
सरफराज को जिनका ताल्लुक
and it will give the
गुजरात से है मैं उनकी कलीसिया को भी अप्रिशिएट करता हूँ और खुदा के खादम भाई सरफराज को भी अप्रिशिएट करता हूँ क्योंकि पूरी दुनिया में इस कलाम पर अमल नहीं हो रहा.
Yeah. For the external gas module, you are measuring the internal CO2, okay? Or you are measuring the inspiration and expiration CO2, for example, and inspiration and expiration anesthetic agent as well, right? But for the internal one, it will take the sample before going to the patient. I mean, from the machine side. Yes, this is the difference between the internal and external module. Even some other competitors like Draeger, they have GMZ, they have two anesthetic gas analyzer or gas module inside the device, one internal and one external as well. Because they have also the auto flow system, which is similar to the automatic control anesthesia. So there should be a measurement from the internal of the device and also continuously comparing with the patient measurement and the machine going to adjust the parameter according to the feedback from the patient.
So on the ACA, we need internal and external gas module?
Yes, it's mandatory. But for the A9, A8, I don't think that the machine will come without internal AG module. So this is the AMV ventilation mode. This mode that we have in our A9 and see the machine or A8. Volume control ventilation, tidal volume down up to 20 milliliter. Pressure control ventilation, BCV, tidal volume down up to 5 milli. Okay, pressure regulated volume control, BCV, VG. Synchronized intermittent volume mandatory ventilation, volume control, and pressure control as well. And also SIMV with volume guarantees. With volume guarantee that mainly they are using the SIMV with volume guarantee for the neonatal or premature babies. Okay, because usually the doctor cannot predict the exact tidal volume of his lung. Okay, so he will give him a pressure, okay, with a volume guarantee to predict that by giving this amount of pressure, I'm guaranteed that I will reach this amount of tidal volume. This is the SIMV with volume guarantee. Okay, pressure support ventilation, continuous positive airway pressure, and CPAP, airway pressure release ventilation, and adaptive minute ventilation. These are optional. Okay. Set the ventilation mode in 2 steps. Set the control parameter via knob or via touch screen or via quick set key that already configured by the doctor when he made his profile. Okay, and here the doctor can decide which mode they are using frequently. He can select the mode that being used frequently in the OR, in this department, for example. Click in ventilation mode area, select ventilation mode to be displayed. VCV exists by default, so the VCV is by default, so that's why it's blindly here, cannot be modified. And a maximum of 8 ventilation mode can be displayed at the time. So all these 8 ventilation mode will be appeared here. There is some hidden mode because the doctor is not configuring, not selected. Here, this is all our user operation, by the way. Okay, setting the range of the beep, of the parameter as well. Okay, airway pressure release ventilation. This is APRV mode, which is optional. Okay. What's the main idea of this mode? By incorporating short expiratory phase of the ventilation, increase venous return, cardiac output, improve CO2 elimination, and prevent expiratory collapse of the airway. Okay, so for this mode, mainly to release the CO2 from the patient fastly, and also they are using for the patient who has chronic respiratory disease. It's like some patients have collapse in specific portion of the lung. Okay, so they are using APRV, airway pressure release ventilation. This is adaptive minute ventilation. The doctor has to set only the target minute volume and the beep, and then the machine can work by itself to reach this minute volume. Okay, all this clinical. This is the adjusting of minute volume and beep. Okay, so this is the CPB or cardiac bypass mode. Usually, if the patient in the cardiac bypass surgery, okay, the doctor want to eliminate all the alarms of the machine. Okay, usually they are using manual ventilation mode, but sometimes they need to use also automatic control ventilation. Okay, but they don't want to see the alarms at the screen. Mostly used in cardiac surgery, clear prompt when bypass is on, the volume, pressure, apnea alarm are disabled. The FI, ETC2 low alarm, FI, ET anesthetic agent alarm are disabled. So all the alarm are disabled during the bypass surgery. So this is the main concept of the cardiac bypass mode. Because the doctor, they don't want to see the alarm during the bypass surgery. Okay, bypass only be enabled under manual mode by default configuration. Bypass can be enabled under automatic mode if change the configuration of the system menu. Because the recent clinical research shows during cardiac bypass, a certain mechanical ventilation can protect the lung. Okay, this is the ECGO. Connect to non-rebreathing circuit, mostly used for pediatric and neonatal. Some doctors are calling it direct breathe. Okay, so there is specific circuit can be connected to this outlet. Okay, and they will switch the ECGO on, and the patient will breathe directly, and the doctor gonna ventilate him manually, but the gas will not be rebreathed. It's like open system anesthesia. Is it clear?
Yes, clear.
Yeah, and usually in the circuit there is a connection to connect this open system anesthesia to the LCGO to protect the stuff. So any exhaled gas will go to the AGS system. It will go to the AGS test, not inside the room. This is some tools for lung recruitment. Sustained inflation, beep incremental. These are purely clinical feature. In the ventilator, we were using this. We were using some of these features like sustained inflation during the weaning process. Okay, and here, for example, some patients have some atelectasis in the lung or have complication of his lung, so the doctor leads the doctor to use this feature, like a lung recruitment, sustained inflation, beep incremental. So lung recruitment tool are in pro, beep stepwise. So all of these are purely clinical feature. I think also the application or the clinical application specialist will be fully aware about this feature to present it to the doctor as well. Okay, this is the lung recruitment tool. Similar to before, sustained inflation maneuver, customized hold time and hold pressure, schedule the recruitment automatically, so the doctor can set the recruitment time automatically. Reminder pop up when the time up. Okay, flow pause. What's the purpose of flow pause? Okay, sometimes there is some treatment going on the patient or some special procedure with the patient. The doctor decides to go through it, so he need to disconnect the anesthesia machine from the patient. Okay, but He don't want all the gases to be escaped inside the rooms because it will affect the clinical staff. So we have this feature called flow pause. Stop fresh gas output and ventilation. When the patient is disconnected from anesthesia machine temporarily, intubation suction for any specific procedure. Why? Because avoid the agent gas output into the operation room, prevent human damage or environment pollution. How long? Default 60 seconds, maximum 2 minutes. Increase, and the increase will be 30 seconds. So if 2 minutes is not enough for the doctor, he just can press the plus 30 seconds. Here, right? Okay. Here the monitoring module that can be plugged in our anesthesia machine.
خلاص ايوه خلاص.
Okay, a module design sharing with the patient monitor, so it's similar to the patient monitor module.
هذا حق باتشا ما
Can be plugged in our anesthesia machine. Ultimate gas monitoring technology golden standard paramagnetic auto sensor maintenance free. So there is a paramagnetic oxygen sensor inside. Do you know what's the difference between the paramagnetic oxygen sensor and the chemical oxygen sensor?
Paramagnetic.
The chemical needs calculation and it has a lifetime. Sorry, it has expiry date. But the paramagnetic, it's not in calculation and there is no expiry date.
Yeah, yes, you're right. So, you know, mainly the concept of using a paramagnet, okay, for elongate the time of the replacing of the of the oxygen sensor, okay, because yeah, as you say, the chemical has expiry date, and the maximum usage of the chemical should be like 1 year as a maximum. After that, it will be defective or it will not measure the oxygen concentration anymore. So for the paramagnet, it's not it's non-replaceable. I mean, it's maintenance free, okay. And they are using the paramagnet feature of the oxygen molecule because the oxygen will be attracted to the magnet. Okay, so according to that, they can measure the oxygen percentage. There is two different procedures. So mainly, they are using permanent magnet as a paramagnet oxygen sensor here in Mindray, while in Drager it was pulsating magnetic field, and here it's permanent magnetic field. I will try to demonstrate it somehow. Okay. So, imagine that this is the magnetic field. We have the poles of the magnet, okay, and the gases is going inside from here. These are the fresh gas, okay? And here, I have two spheres, okay? Two spheres connected together. This sphere has nitrogen, and two, okay? So once let's say the atmospheric air is going inside, it has 21% of oxygen, okay? So this one will be rotated because there is 20% of oxygen going inside. This is from the room air, okay? So at this rotation, I will measure the torque of this rotation, and they will register this is 21% of oxygen. Okay, by increasing the oxygen percentage, this oxygen molecule will be attracted to the magnet. Okay, and the rotation speed will be more. Like for example, 40% oxygen. The rotation speed will be more, okay, and the torque, the measuring torque, will be different than 21% of oxygen. Okay, so at that time I can measure the 40. Once I increase more, let's say 50, the torque will be increased and the oxygen molecule will be attracted to the magnet, and there will be a continuous rotation. and the torque is different than 40 and 21. According to this, they will measure the oxygen percentage. Is that clear? I hope so.
Yes, yes.
Yeah, so this is the principle of paramagnetic oxygen sensor that they are using in Draeger. In Mindray, sorry. In Draeger, they are using pulsating magnetic field. It's totally different principle. But at the end, it's paramagnetic oxygen sensor as well. Okay, I did 5. Yes. Yes, tell me.
I installed 2 Mindray instrument machines in our country,
Yeah.
and I connect the machine only to O2, but the gas module reaches the O2 about 70, 60, no, not 100 O2. So I decided to calibrate the gas module O2. So I'm questioning why the calibration, why the gas module is not calibrated in the country.
Usually it should be calibrated in the factory actually. So this is, yeah, because you know, in order to calibrate the gas module, you have to use the gas cylinder. Okay, the gas cylinder for or we call it calibration gas. Okay, and this gas cylinder is difficult to ship it between the countries actually. Usually it will be stuck in the customs, let's say, because they can consider it as a harmful or something. So usually this agent has to be calibrated from the manufacturer. So in that case, if you have such a problem, you are able to raise QE order to replace this gas module.
Replace to the factory? Return it to the factory?
Yeah, if your machine is under warranty and you receive the gas module and you are making sure that you have 100% pure oxygen, because sometimes, you know, we faced this before, sometimes the hospital are using oxygen concentrator, okay, instead of oxygen cylinder or liquid oxygen tank, okay, and they will never reach 100% of oxygen.
Okay,
so if you are making...
maybe above 90. But the gas module give me 16, 17, not even close.
Okay, what about the accessories of the agent module? I mean the water trap, the sampling line.
Yes, it's very good and tighting. The problem is only in the oxygen reading. The agent reading is good, but only the oxygen reading.
Yeah, did you try with other oxygen?
Maybe this problem happens 2 times on 2 different gas modules.
Okay, you have only these 2.
Yes, but now I made a calibration, and now it's working.
You made the calibration? How you made it? You have the gas cylinder, yeah?
No, because the machine to the only O2 and select about 100.
Oh, okay. Yes, okay. Good. Okay, but usually if you are struggling with these issues and the machine is coming in new and it's not calibrated, even if you do the calibration with 100% of oxygen and it's not working, you have to raise a QA order and it will be replaced for sure. Okay. The monitoring parameters like CO2, O2, nitrous oxide, anesthetic agent, and NAC with the age correction. Okay. Waveform include CO2, nitrous oxide, oxygen, anesthetic agent. Okay. This is the PACE or bispectral index. They are using to make sure that the patient is in sleep condition or it's indicated if the patient is not yet reached the deep anesthesia, because they avoid to go for deep anesthesia for too long time. Indicate anesthesia too deep indicate recovery. So there is some parameter of measured by PIS module to indicate the depth of anesthesia of this patient. Okay, it's like some electrode glued on the patient head, and they can see this PIS measurement. Okay. Neuromuscle transmission, this is to make sure about the muscle relaxation of the patient. Okay, so it's like giving the patient pulsating of current, of small current, and if the patient still moves his finger, that means he is not in complete muscle relaxation until it's muscle and nerve relaxation also, until he stops move his finger during the pulsating of current. That means yes, he is completely muscle relaxed. This is the concept of NMT module. Okay, this is some parameter measured by NMT module. Okay, transpulmonary pressure monitoring. Okay, we have this feature in our A9. It's configuration, or it's it's configuration. So sometimes your machine will come without this auxiliary pressure port. Okay, so it's configuration of order. If they wanted to have the auxiliary pressure port, it should be from the beginning while the salesman configure the order of the anesthesia machine. It's option. It's not standard feature. So what's the usage of this auxiliary pressure port? Actually, it will measure. It's like catheter, and they can use it to measure the esophageal and the gastric pressure. Okay. I mean, this is the pressure surrounding the patient lung. So by measuring this pressure, the doctor can decide the optimal beat for this patient. This is the main feature that they are using the auxiliary pressure port. Okay? If the machine configured with the auxiliary pressure port, your monitoring PCB or sensor interface port will be different than the standard machine, because of course I will have one more sensor to measure the auxiliary pressure. Okay? Clear? So this is the main usage to reach the optimal beat of this patient. So it will measure the esophageal pressure and the upper gastric pressure. So it will measure the pressure around the lung or surround the lung to decide the optimal beat for this patient. Okay.
So can we have this transpulmonary on the Pro version, Mohammed?
In the Pro version, what do you mean? Vato or the new anesthesia?
Vato series. Can we have this?
No, I don't think so. I think it's only in the A9. This is similar to the one which is available in the SV800 version. We have this in the SV800 version. Yeah. But in the Vato, no, we don't have it. We have it in the A9, A8 only, and also they will have it in the new A5 and A7 as well. Okay. Yes. Agent and gas consumption. During the surgery, the agent usage speed and surgery, the total consumption and cost agent, the total consumption of gas. I mean, after ending the surgery, the machine can give you this. Okay. So how many milliliters they consume of SIVO, for example, of SIVO, of ISO, of the oxygen, how many liters they consume during the surgery. So this is like a summary about the usage of the gases.
2 hours 10 minutes.
Okay, and also they can know the cost of the usage of the gases, as seen here. Cost per milli of liquid of agent, so they can identify the cost. Is that clear? Alarm management. Adjust the alarm limit via press the alarm button. Okay, adjust the alarm limit quickly. Press the flashing parameter, which is currently alarm, the related alarm limit in adjustable status, press the flashing parameter, okay, and you are able to adjust the alarm.
Trainer is changed.
Okay, auto alarm limit, benefit customized alarm limit for each patient, reduce false alarm, available in volume control ventilation, pressure control ventilation, and pressure control with volume guarantee. The parameter in formula are all major parameters. The new alarm limit for power are calculated on the basis of average value for peak, plateau, and beep. The value used for average uses, the value of the last 4 ventilation cycle are the value in 1 minute. Okay, so this is auto adjustment limits based in the history measurement. Okay, you will just select the alarm and press auto adjust. Okay, auto set. Instead of adding number like the upper alarm or lower alarm limit, you can just press, or the doctor can just press auto set. Okay, this is the graphical troubleshoot I mentioned before. If there is alarm, there will be a graphical troubleshooting, like the tube king. This is just to guide the doctor to troubleshoot with the problem. Okay, pre-use system check. Okay, so this check, daily check, and each patient check. Sometimes, a lot of time, we have problem that the doctor say, for example, there is a leakage during the surgery, and I'm sure that it's not technical, it's not user-related issue, it's technical issue, and we need to investigate and all this stuff. And when we export the log, we find him that he didn't make the system check before the patient connected, or at least they have made the system check at 7 a.m. for example, and this surgery was at 4 p.m. and the leakage happened during this surgery. So the last system check as per the log exported was in 7 a.m. So mandatorily they have to make the system check between each patient. Okay?
Each patient.
Of course, the doctor will say it's taking some time and we are in a hurry and something. At least they have to do the leakage test between each patient before each patient connection. Okay, so inspect the system before each patient, system check before each patient, daily check. They have to inspect the system, they have to system check, power failure alarm, pipeline test, basic ventilation test, flow control. These tests have to be done at least 1 time per day. Okay, and these tests has to be done before each patient. Okay. So system check, comprehensive check all items. Leak test, system leakage and circuit compliance test. Rapidly check system leakage after changing the braking tube. So after changing the braking tube, we have to do the system leakage test. Because system leakage test result is used for the optimizer. Okay, so let's say that I have a leakage within acceptable range. By the way, if there is leakage within acceptable range below 200 ml, okay, per minute, that will not appear as a value in the system check. We can get this value by the log only. But if the leakage is below 200 ml, you will not get any value, you will just get pass. But the optimizer will use this compensation value during the calculation of the, let's say, sufficient fresh gas flow, because this is the main job of the optimizer, to calculate the sufficient gas flow, sufficient fresh gas flow, by taking into his account that there was a leakage of, let's say, 130 ml per minute, which not appear in the system check, but optimizer will take it in his consideration while calculating the sufficient or the required fresh gas flow. Is that clear? Vaporizer test, vaporizer function test, and leak test, auto system check, preset the schedule time of next check. So we have also auto system check. So in case the doctor decides to make the system check at 4 p.m., let's say, he will just enter the date and the time and do the required configuration for preparation or required preparation for the system check, and then the machine will do the system check once reach the set time. Okay. Preparation for system check, close the plating circuit and just the APL valve 230 centimeter H2O. Same preparation required in all tests, system check, leak test, and vapor test, and auto system check. Because we have system check, leak test, vaporizer test, and auto system check. So system check is including all of these, okay? But we can also go individually to leak test, vaporizer test, okay? And we can set also the auto system check. Okay, so the set is to set the APL valve to 30 centimeters to O. Same preparation requirement for all the tests. Okay, then we can start the test. And here in the A9, A8, we don't need to switch between auto to the manual because we already have micro switch inside that will do this job. So we need to adjust from auto to manual. Okay. This is the fully system check. All the items are completed within 3 and 5 minutes only. 3.5 minutes. Okay. Simple, automatically performed by system without manual intervention and schedule system check to save preparation time. Okay. So if the doctor decides to go through the auto system check, he will just identify the date and the time, okay, and to prepare the tube connection and set the ABL valve to 30 centimeters to. Then, once the machine reaches 4 p.m. for example, it will start the system check by itself. Okay, but the system has to be in standby. Okay, and yeah, and switch it on. Of course, if the machine is switched off, it will not do the auto test. Okay. So these the items that the system will go through during the system check. Hardware, valve, sensors, flow meter, gas supply, power supply, AG module, AGSS, all these items. Okay. So in case of failure, also in case of small failure, sometimes the machine fails the test. 210, for example, or 230. So okay. Some if it's below 200, it will pass. The machine will be able to compensate the leakage completely, and you are able also to use the
already on morning time. This one lady on.
Okay. Sometimes I will get like a graphical description of the failure or the leakage. For sometimes I will get like a picture of the gas module and a sample line return. So it will advise you that
asking
might
ID
cause the
number.
leakage.
Next asking extension number.
Okay.
Calling. IT.
And here, for example, the manual leakage fail without adjustment from auto to manual because there is only micro switch. It will do this job. Adjust from auto to manual.
No, it's not mine.
Okay.
No,
so
before you.
This is non-functional.
Also very old, I think.
You will repeat the test and then it will fail and you are able only to access the service menu.
Still okay.
I mean, the doctor cannot repair this machine, or it's not a matter of fixing some tubes or something. So there is some hardware failure inside the device, and it allows you to access the service menu only. To explore the log, for example, or to go through the diagnosis or valve test tool, or to go through the constant flow test.
Because all engine go for the
system check, pre-operative checklist performed by user. Okay, so we have the system check and we have the pre-operative checklist to guide the user to do it per the patient. After performing the system check, they have to check, for example, the auto cylinder, check the CO2 absorbent, check the vaporizer and the agent volume, check the unidirectional door valve, which is in the braking circuit. Okay. And check auto sensor reading the room air, test low oxygen concentration alarm. By the way, if the machine is configured with the AG module, it will not come with the chemical oxygen sensor. Okay. system leakage circuit compliance test. Yeah, this is the what I told you before, system leakage result using as the input for optimizer. Yes. Auto system check, how to configure it, just select the auto system check and you can select the day and time. Once reach that time, the machine will start the automatic system check by itself, but we have to take in consideration this point. If exit standby mode before the next test, the scheduled test will be cancelled.
No.
Okay? So if the doctor has configured the auto check,
Outlook
will come like this. Automatic system check will be on day, blah blah blah.
No.
So if the doctor exit the standby mode, this will be cancelled. So he has to prepare this for the automatic system check and make the machine standby. Okay, if the system is turned off, the scheduled test will be still available if the system is turned on again before the
morning
and
or
also
evening
if the user
time
performs the
today.
test before the next test, the scheduled test will be cancelled.
Still say
So,
Raisar Mafi.
the doctor has to only set the time of the automatic system check
Okay?
and no need to exit the standby and no need to do the system check
No,
manually
your problem.
in order to activate the auto system check next time. Okay. Vaporizer test, to test the back pressure
How
test
much
of the
storage your
vaporizer.
mobile? 4 hours?
Okay, or to test the ability of the
New
vaporizer.
mobile,
This
this
is
one I did
in
not
case
use.
if we are using the,
Raisar Mafi. Raisar, storage pay?
in case if we are using the A8 vaporizer, or in case if we are using the pneumatic vaporizer.
You are coming
So,
29
set the auto flow rate to 6 liter per minute. This is to test the backup pressure.
Biomedical engineering day, Mafi decorate.
Or to test the stability of the vaporizer. Adjust the vaporizer
Engineering day,
concentration within
biomedical.
0 to 1%. Ensure that the reduction in oxygen flow rate is evaporating. The concentration does not exceed 1 liter per minute during the adjustment.
I'll ask. There is international day for the biomedical engineering. Same like nursing day.
Okay? So, you will set 6 liter per minute and put the vaporizer concentration from 0 to 1. Okay? And ensure that there is no difference of more than 1 liter per minute of the oxygen flow. If it passes, then turn off the vaporizer after the test. That's it.
Same password?
Clear?
ABCD?
Are you with me, guys?
So ask the rest.
Yeah.
Yes.
Okay. Vaporizer leak test. Set the auto manual switch to manual, turn off the ACGO, set the ABM valve to spontaneous position, attach reservoir back to manual arm, seal the white shape connector. The output setting of vaporizer should be at least 1%. Set the flash gas to 1. Okay, by the way, all these, I mean the vaporizer test also will be considered as a system auto or the system check. So system check comprehensive test include the vaporizer test as well. Or otherwise, if you want to do the vaporizer test, you have to follow the instructions.
You sir?
You like cake?
I don't like.
Okay.
This is lemon.
ABM valve test. Enter the standby mode, set the auto manual switch to manual, attach reservoir back to manual back arm, close the Y-shaped connector, or similar to the set of the leakage test. Okay. Adjust ABL valve to 30 centimeter, press auto flush button until the reading on the bow gauge is within 20 to 40 centimeter range. Rotate the control knob of ABL valve to fully open. Set auto flow rate to 3 liters per minute. Turn off all the gases. Make sure that the reading of the airway pressure gauge is less than 5 centimeter H2O. This is how to test the ABL valve.
You know, Masri,
Press
they
and
like
hold
that.
the auto flush button to ensure that the reading on the bow gauge does not exceed 10 centimeter. Set the auto flow to 0 and ensure that the reading on the bow gauge does not drop below 0. It's only instruction you have to apply it. That's it.
So in the data check,
Yeah.
the machine will check all this automatically?
It will check these This is what's going to be checked by the daily check. But plus the daily check or plus the system check, there is a pre-operative check. Just a moment. This.
I mean when the machine doing a system check.
Yeah.
It check all these tests we're talking about. Automatic.
The vaporizer will be checked. Also, the ABL valve will be checked automatically, because if the ABL valve is not 30, the machine will fail the test for sure. Because we have to set 30, and if the machine detects that the ABL valve is not within 30 centimeter H2O, it will fail the test as well. So it's included, yes, the ABL check. Inspect the negative pressure suction device. So this is daily check also from the end user. They can inspect the negative pressure suction, the venturi suction of the negative pressure suction. Set the switch to rig, adjust the control knob to maximum, and check whether the pressure gauge reading is increased in the integrated suction device. Pre-operative preparation, confirm the relevant parameter and alarm limit setting on the anesthesia machine. Make sure that the anesthesia machine is in standby mode. Set auto manual to manual, attach the reservoir back to the reservoir port. Turn off the vaporizer. Rotate the ABL valve, the ABL flusher to spontaneous position. Turn off the fresh gas flow meter. Okay. Power failure alarm test. Set the system switch to on position. Disconnect the AC power supply. Make sure the AC power and battery indicator are off. The alarm sound is generated, should be displayed on the main screen. It's very easy test. For example, this the power failure alarm, just to disconnect the power and make sure that there is alarm generated on the screen. And also the indicator of the AC power and the battery is off. That's it. Gas supply test. This gas supply test is important actually, because for example, sometimes this is the proper range of the gas supply, 280 to 600 kilopascal. Okay, so sometimes we are in a threshold. For example, sometimes the gas supply is 290. Okay, and they want to make sure that this gas supply will not be dropped during the surgery, especially, for example, for the user flow calibration, okay, or in general for the calibration, I'm using very high flow, okay. I'm using, for example, for the flow sensor calibration, I'm using up to 120 liters per minute of flow, okay. So if I'm in the minimum range of the pressure, I want to make sure that the pressure will not drop during the surgery. How to make sure? For example, I will set the airflow to 6 liters, check if the air pipeline pressure gauge is within 280 to 600 kilopascal, cut off the gas source and verify the alarm auto supply pressure insufficient or drive gas pressure is low or displayed. Make sure the pressure gauge return to zero position. And by the way, you can just hold on the auto flush button, okay, for some time, and make sure you are not getting any alarm of drive gas pressure low. That will be efficient to make sure that your oxygen supply is within the range. Because in the oxygen flush, I'm using a flow of oxygen up to more than 50 liters per minute. Okay, so if while I'm pressing the auto flush, there is no drop in the oxygen supply, that means my oxygen supply is sufficient. Is it clear? Especially sometimes reported that the flow calibration is not passive, flow sensor calibration is not passive. And we find in some cases that because of, they are within the range of pressure, but they are in the minimum range, and during the calibration process, the machine uses very high flow. That's why the calculation is not passed. So we'll tell them, please, if you can adjust the output of your cylinder supply, for example, or of your main gas supply. Is it clear?
Yes, yes.
Yeah. Basic ventilation test, install the breathing circuit and breathing bag, connect the other test line or breathing bag to the patient and end of YPs, at the end of YPs, set the auto flow rate to 3 liters per minute, set parameter as follow. Okay, start ventilation and verify the P plateau and air on the test screen of the anesthesia machine. Rating on the blood pressure gauge is within 18 to 22. Okay, this is also the ventilation test. You can follow just the instruction in the operation manual, or the doctor can follow the instruction in the operation manual to see the tolerance as well in the ventilation test. Similar to the ventilation test that we are going to do during the installation.
Hello,
Flow control system test, connect the pipeline supply or slowly open the cylinder valve, set the system switch to on position, select the fresh gas flow zone and set the fresh gas control to direct flow, set the balanced gas to air, adjust the air, make sure the flow increase fluently, set the balanced gas to nitrous oxide. By adjusting the nitrous oxide, automatically the machine will adjust the oxygen concentration. Because for all device we will have the SORC, which is specific oxygen ratio controller. Okay, but for the new device, this specific oxygen ratio controller will be controlled by the EFCS control board. Okay, so for safety, I'm still having the hypoxic graph. Okay, which control the oxygen to nitrous oxide range to be 1 to 3. So that's mean I cannot increase the nitrous oxide flow more than 3 if I have 1 oxygen. So 1 liter per minute of oxygen. Of oxygen I can have 6 liters. So this is the ratio 1 to 3 or 25 to 75%. Is that clear? So in this machine we don't have ORC hardware, but it is managed by EFCS controller. Oh. Okay, flow control system test. That means I'm testing the BFCS if it's working or no. Open the BFCS cover, start the BFCS and make sure the prompt message of BFCS is in use appear. Make visual checking to ensure the total flow shows basal flow of approximately 1 liter per minute. As I told you, there is a basal flow of oxygen in the BFCS mode. Because of safety, I have at least 1 liter per minute of oxygen. Adjust the air needle valve, increase the air flow gradually and make sure the total flow can rise to more than 10 liters per minute. Close the air needle valve. Okay, you can just follow this instruction. It's clearly mentioned in the operation manual, not only the service manual. So this has to be fully aware by the end user as well. Okay, this is daily test, alarm test. Prepare for alarm test, auto concentration monitoring and alarm test. Minute volume to low alarm test. Apnea alarm test, continuous air. This alarm steps, please refer to operation manual chapter 15.11. So they can go to that operation manual and follow the instruction to test the alarms. The maintenance. Okay, the available upgrade, the user maintenance, factory maintenance, tool, replace, maintenance kit, calibration, and test, and report template. Report if there's an incident or if there is a failure, you want to report it. Okay, this is the available software upgrade or software function. Like, for example, if they want to activate the CPAP or pressure support, there is activation code. Okay. We need only the machine ID, serial number, and MAC address. Usually, we are using the serial number and MAC address. no need for the machine ID, but they are mentioning it here. So the most important thing, we will ask you to get the serial number and the MAC address of this device. Okay. After that, we will generate the code. Whether by you can type in the code, or you can just plug in the USB and import this function. Is it clear?
Yeah.
So here, ACA, for example, automatic control anesthesia. Why it's only available in A9? It's not available in A8.
Because A9 has internal agent.
Also, A8 has internal agent.
And is it funny for the vaporizer?
Yeah, exactly, because of electronic vaporizer. Because the machine will adjust the anesthetic agent concentration by itself. Here. Okay, software activation from service, go to setup, license. Okay, insert the function flash drive in the machine or type the activation code as I told you. That's it. Flow calibration, flow sensor calibration. Okay, performed by user graphical instruction. Okay. So in the A9 or A8, why we are doing, let's say, the factory or service flow calibration? We don't need any calculation device. Why? While in the water, for example, if we are using calculation device to do the factory flow calibration. Think of it. Similar to the ventilator. No? Similar to the ventilator.
Any more food left? Just one left?
Leave for
One for me, one for me.
Okay,
You don't eat all.
inside the machine,
You don't eat all.
internal
Yes,
processor
you
that we
don't
have
eat all. I
the
know.
drive
this is for
gas, the drive gas part
this is
of the
no
ventilator.
chicken, only
Okay,
rice.
it's TSI
Only no
flow
chicken.
sensor. Okay,
No.
so TSI flow
Only but
sensor
I get
that we are using it for the calibration device as well.
Rice or
The
chicken?
calibration
Yeah,
device,
chicken.
they are using the
Yeah,
TSI flow sensor. So I have heated wire flow sensor inside the device, and this is my benchmark. So while calibration the
Okay.
expiratory and inspiratory flow sensor, these are differential
No,
pressure
no,
flow sensor.
no, this for
Okay.
chicken if you want.
You know the difference between differential pressure and heated wire flow
Yeah.
sensor.
That's it for chicken. Chicken.
Do you know it?
Not for meat, for chicken. Yeah, you put security.
Who had chicken?
Security.
I can explain it. Okay.
Security man?
So
Security, one of
Ah.
the security, yeah. Thank you.
Okay, welcome.
Salam alaikum.
Walaikum assalam.
Okay.
I'm not good in drawing, but I try. Okay, this is the flow sensor of the external flow sensor. I mean the inspiratory and expiratory flow sensor. Okay,
I keep one for
and
Rosa.
here this tube will go to the pressure sensor, and that one will go to the pressure sensor as well in the interface port. So this
Yes,
is
doctor.
the sensor.
Roy is here.
Right. If you
So what's
buy
the
charger,
concept of measuring
Charger
the
for what?
pressure here, the differential pressure flow sensor?
Thank you.
Here I have some small sphere, okay? Or let's say small diaphragm or small plate or whatever you name it. And here I have pressure and here I have
Salas, you give already FM?
okay?
Huh?
So I'm measuring 2 pressure points.
How much
So-
you get?
20 real.
What's the
Oh my
Ohm's law?
god.
Ohm's law is
Good
E
business.
equal
My talent is not
I
20 real.
multiply or V equal I multiply by
But
R.
it's good amount.
Right? I stand for the current and R is for the resistance. Okay. So if I'm having V, which is V,
It's
in
still
the circuit.
moving.
So E equal the flow multiplied by resistance as well. Okay, so I have two different resistance here. Okay, and I have a pressure already, so I can find the flow. Because V equal P over R. This is how to find the flow in the differential pressure flow sensor. Get it?
Correct.
Guys, is that clear? It's clear?
Yes, sir. It's clear.
Yeah? Okay. So now let's go to the other sensor that
Even though not.
the TSI sensor is saying.
Brother, some good, huh?
Bishoy, are you here?
Hard, huh?
Hmm?
Bas.
No, not correct.
Yeah. I know this was.
Yes, yes, Dardona, I'm with you.
Yeah, you remember the spiral life and spiral loop in Drager before?
Yeah, of course.
Yeah, so those are heated wire flow sensors, similar to the TSI flow sensor concept. Okay, so let's say this is heated wire flow sensor or TSI flow sensor. It's more stable than the differential pressure flow sensor. In here, the machine, let's say the machine is started. So in here inside, I have two small wire, two very thin wire. Okay, let's say I'm starting the machine, and this wire started with 70 degrees C temperature. Both wire started with the same temperature. Okay. So one of these wire will be fixed by the device, and the other one will be alternated. Okay, so now this one, let's say it's constant, 70, and the device will keep pushing the current to keep this one 70, and this one is variable. So once there is any flow goes inside, it will cool down this wire. So it will be like 50 degrees C. Okay? So how to calculate the flow then? The machine will think, how much current do I need to stabilize both to 70 degrees C? According to this, the machine will know how much flow do I have. So too much flow, too much cooling down of this wire. It will be like 30, 20, 10. Then the machine will calculate how much current do I need to stabilize or to return back the temperature on the other wire to 70, similar to the second wire. Yes. Sorry? Is this clear, guys?
It's totally clear. It's totally hello.
Yeah.
It's clear. It's clear.
Yeah, it's clear. So, inside the machine, in the ventilator, we have this one, TSI, inside the machine, okay? And outside the machine, or external, we have the inspiratory and expiratory flow sensor. So I'm using this one as a benchmark to calibrate my inspiration and expiration flow sensor. Because this one is existed already in the calibration device. So I have one inside my device, I'm using it as a benchmark. Is it clear?
So, what in the inspirator?
Sorry? We have three, yeah. We have three flow sensors. We have the internal flow sensor, which is TSI1, and we have external 2, which is inspiratory and expiratory. The external are differential pressure flow sensor, and the internal one is TSI flow sensor, or temperature change flow sensor. Yeah. Get it?
Got it. Got it.
Okay, and this is how to disassemble the breathing system and how to remove the volume exchanger as well. Okay, and this is the disinfected part, the disinfected part of the machine that applicable for autoclave as well as seen here, steam autoclavable, also include the volume exchanger. Okay. Okay, factory maintenance tool, standard equipment. Okay, so instead of going to all these slides, I will show you one video for the calibration process. Is that fine?
Good.
Fine.
Yeah, okay.
Fine.
So,
Good.
So why they are?
still you are seeing my screen, guys, right?
We have already service manager for that.
Yes. Like, is the mic of
Service
Autodesk is open?
Yeah.
Okay, close it.
Sorry? Sorry?
The mic of Autodesk is open. Can you mute it?
No. Okay.
Your mic is unmuted.
I think now all are mute or what? Yes? Okay. So you are seeing my screen now, and hopefully it's hearable, not like before. Yeah? Are you seeing my screen? Yeah, and the voice is okay as well, right?
Yeah. Voice is fine.
Disassemble the bag arm and O2 sensor seat. Disassemble the CO2 canister.
Oh, this is most important part.
Disassemble the breathing circuit. Disassemble the volume exchanger. Select the set of O2 soft key. Select the start key to start the O2 sensor calibration. The system will display the calibration status after calibration is completed. Ensure that the system is in standby mode. Select the Set of Calibrate soft key. Remove the water trap. Connect the Y piece on the breathing circuit to the leak test port to close the breathing system. Select the Start key to calibrate the flow sensor. The calibration may take several minutes. The system will display the results of the calibration status after the process is completed.
See, here when she starts the calibration, it's giving alarm auto supply low. That's why I told you we have to make sure that the gas supply is sufficient, okay, to give me a flow of more than 100 liters per minute for the calibration purposes. Because during the flow calibration, I'm reaching up to 120 liters per minute during this calibration process. That's why now we can see the oxygen supply low alarm appear and then disappear. Clear?
Yes.
Select Setup Service and enter the required password to access Select Calibrate. And then select Zero Sensors. Press Start. Wait until the process complete. Connect the A9.
It's configured with the auxiliary pressure supply, okay, or the auxiliary pressure for the esophageal and gas for the esophageal pressure measurement. So that's why the interface PCB include more than the 3 sensors, or yeah. So that's why he need also to connect it during the pressure calibration. You calibrate as well the auxiliary pressure outlet or the auxiliary pressure for this device, because there is a pressure sensor for this as well.
Ensure that the anesthesia machine is in standby mode. Choose setup service. Calibrate pressure, calibrate, press start. Wait until the process complete. If customer side has N2O supply, then it is necessary to perform total flow sensor calibration. Find flow sensor calibration in service menu. Make sure O2 N2O supply is enough and press start.
It's not clear now. It's blur.
Connect hoses and insert Y piece into leak test plug to close the breathing circuit. Select setup service and enter the required password to access service menu. Select calibrate and then select expirate valve calibration. Press start. Wait until the process complete.
Speaking for expiratory valve calibration, there is some cases raised to us that there is ETCO2 high alarm in the device. Okay, they already cross-checked the soda line canister, they already cross-checked the bypass of the soda line, they already cross-checked the AG module, but still the problem exists. Okay, so the problem was from like there is expiratory retention. So after performing the expiration valve calibration, the problem solved. That's why in the newest or the latest software of the A9, okay, the expiratory valve calibration is happened during the system check. So they corrected in the new or in the latest software of the A9 to perform the expiratory valve calibration as one step in the system check. So automatically performed during the system check.
In service menu, select diagnostic test valves. During troubleshooting, valve test is often used to locate valve or sensor related failures. Connect high pressure O2 supply and make sure the gas supply is sufficient. Remove the water trap. Use a pipe to connect the inspiratory port and expiratory port of the anesthesia machine. Set auto manual valve to auto. Set safety valve to on. Set peak valve pressure to 50 centimeter water. Set inspirate valve to different flow to check if the reading is in the range or not. If readings are out of range, perform flow calibration.
Constant pressure.
Connect the A9 and calibration device the same as pressure calibration. In diagnostic test, set peak valve to different pressure and check if the pressure sensors reading are in the range or not. If readings are out of range, perform pressure calibration. Prepare a U-disc to get log. Plug in USB to USB port. Select Setup Data Transfer Export Data. Enter in.
This is how to export the service log. Okay.
Engineer password. To ensure long-term reliability and stability of the ventilator, periodical maintenance maintenance of the equipment must be performed by authorized service engineer. Please read the service manual for more details.
It is helpful video, right, guys?
It's available on YouTube.
Yes.
They have mentioned all the calibration process that we do.
Yes.
So, do you like to have one more break? And then we can go to the... Yeah, then we can go to the service part because the remaining is only for the calibration. Yeah, so we can have one break.
Okay.
A break.
For 15 minutes.
Lunch break.
Half an hour. No,
It's already lunch break.
Okay.
Yeah, after 15 minutes we'll come back.
Hey!
Okay, lunch break.
Kulit na?
Ano, na-unbox mo na? Hindi, yung ano mo?
Wala pa.
Ha?
I'm not sure, Roy. Kung kaya ang hours niya, tawa.
Ito lang?
Para lang naman ko sana. Hindi siya. 20 hours siya. 12 hours ang microphone. 12 hours ang ano.
Hindi, yung ano, na-unbox mo na?
Wala pa lagi. What? Look mo kung sumat lang. May pagatong gibilin diri, Roy.
Okay na yun. I-unbox mo na yun doon.
12 hours na di ang kuha niya ato.
Because the issue is 1 to 0.
Maintenance factory calibration
Okay.
test.
Adjust the nitrous oxide flow to 0. Close the nitrous oxide cylinder. Cylinder pressure gauge reading decrease should be smaller than 10% in 1 unit. This is how to check the nitrous oxide cylinder supply test. Adjust nitrous oxide flow to 6 liter per minute again. Confirm when nitrous oxide pressure fall and to pressure low alarm appear. Confirm cylinder pressure gauge reading could reach 0 pressure at
If I have wings.
Okay, because they already closed the
You don't have a feather,
6
you have
liter per
wings.
minute of nitrogen nitrous oxide. So I will read 0 because there is no nitrous oxide in the line because the cylinder is already full and I will get alarm nitrous oxide pressure low.
No, wings.
This is also the oxygen cylinder supply test. Remove auto pipeline, install backup cylinder, and in AFCS mode, adjust auto flow reading, increase the
Auto flow
You
calibration.
need deploy PFCS. Okay, deploy PFCS means that just open the door of the PFCS. Okay, then the system will go to the PFCS mode. Okay, check 1 liter per minute basic flow. As I told you before, in the PFCS we have 1 liter per minute basic flow. Usually we have adjust the auto reading valve, auto flow reading increase closely. Adjust the auto flow to 0, close the auto cylinder, cylinder pressure gauge reading decrease should smaller than 10% in 1 minute. Disable the VFCS. In the VFCS mode, adjust the flow to 6 liter per minute. Confirm when nitrous oxide pressure fall, auto pressure low alarm appear. Confirm cylinder pressure gauge reading could reach to 0 at the last. Similar to the air, and here is the vaporizer test. Also, we have a document for the vaporizer test. Okay, so similar to before, we already mentioned the vaporizer test step. Auxiliary flow meter test. Link O2 and air pipeline. Because we have auxiliary, auxiliary air O2 and we have HFNC, right? Link O2 and air pipeline, open O2 and air backup cylinder, link calibration device to auxiliary flow meter outlet, the press auxiliary flow meter switch, active the function without operation, floater in the meter should stay at the bottom. Set the O2 to 100% flow rate of 15 liter per minute, floater in the meter could reach probably calibration device flow reading. So we will connect the calibration device and we compare the measurement. Should be 15 plus minus 2 liter per minute. Okay, because for auxiliary oxygen or air O2 or auxiliary O2 air or air O2, Maximum flow rate we can reach is 15 liters per minute, while in the HFNC, if it's mixed up with air, we can reach up to 100 liters per minute. Okay, so while we connected the calibration device, we should read 15 plus minus liters per minute.
Yeah, take 5.
Again, auto concentration reading should be 100 plus minus.
Let's say somebody take 4.
5%.
Yeah, Assalamualaikum.
HFNC's test, link O2 and air pipeline, open O2 and air backup cylinder, link calibration device to HFNC. Press HFNC switch, active the function without operation, floater and meter should stay O2 and O2. Set the O2 concentration to 100. Flow 60 liters per minute, floater meter and
this one for me. I'm eating this one.
Probably calibration device
This one here.
60 liter plus minus 8. This one tolerance 8. Auto concentration reading should be 100 plus minus.
Nag-iwan siya ng isa eh. Kinuha na yung tatlo. Ito. Walang bawas to eh.
So internal aging module test. Link O2
Ano to? Parang bake?
Open
Tinisting ko
oxygen
nga
backup
patics
cylinder.
daw eh, patics.
Connect AJS test to hospital's imaging system. Auto manual switch to manual. ABL valve to spontaneous position. Link breathing tube. YPs to test port similar to the leakage test. Exit standby mode. Vaporizer to
Iniwan ni Ryan kasi
percentage.
kinain ni kinuha ni yan eh.
Service diagnose AG. Confirm AG sampling. Flow should be 150 plus minus 5 milliliter per minute. This is the internal EG flow rate of the pump. Okay. Confirm EG reading in this stage should be correct and in range of 0.8 to 1.2 percentage of concentration of the anesthetic agent. So I have 1.2 tolerance. Here. All these test steps are mentioned clearly in the service manual, and some of them are mentioned in the operation manual. PFCS basic flow test, connect O2 supply, or open the backup O2, turn on the PFCS, check whether the floater of the total flow meter is near to 1 liter because I have 1 liter basic flow. This is electrical safety. I think you are familiar to do the electrical safety. Okay. Simulated ventilation test, fresh gas setup.
Naglubat na ako.
This is exactly similar to the ventilation test that we are doing during the installation of the device. EFCS accuracy test, switch the motor to manual mode and exit standby. The manual arm interface is used for atmosphere. Okay, so the manual arm interface will be freely off the back. Okay, adjust the fresh gas flow according to the following table and enter the data monitor menu to observe the flow display on the instrument flow meter. Meet the acceptance criteria as per the table state. Also, this available in the service manual. You can just follow it. For saving time, I prefer to go through the service training. This calibration we already introduced in the video, and we'll go now up to the service training for the blue diagram. So this is only the flow calibration and pressure calibration. And this is the expiratory valve calibration. So in case if you are having a device that given ETCO2 high and you already replaced the AG module or cross-check the AG module and you are already cross-check the canister, for example, and the bypass assembly and still you are facing ETCO2 high, we advise to do expiratory valve calibration. In the latest software, which is 1.26, for the new platform A9 and A8, this feature automatically done in the system check, the expiratory valve calibration. Okay. So for the installation part and daily and the operative tests already done. Now we'll go to the service. Training. Guys, is there any question about product installation?
I think it's already okay.
It's clear, so we'll go to the service now.
Yes.
Okay, go ahead.
Okay.
Okay.
Andiyan pala yung sinasearch.
So I present the following, the pneumatic diagram also include these 5 parts, the gas supply, fish gas system, drive gas, breathing system, and others like HFNC, like AJSS, like suction. Then we'll go to the hardware, the electronic circuit of the device, the port introduction, the software upgrade. Then at the end we'll have the troubleshooting, and after that we'll go through the case sharing. Okay. So this is the block diagram of our A9 and CD machine. By looking at it, it's a little complicated, but if we separate it to part by part, it will be much easier for us. Okay. So now we have the gas supply. Okay, and we have the fish gas system, which include the EFCS or BFCS, okay, including the vaporizer manifold or the EVAP, okay, and then we will have the drive gas system, which we call it ventilator, and see the ventilator, okay, then we will have the braking system, the AJSS. Okay, so let's go through the gas supply. Okay, the gas supply system function. To filtrate the gas, okay, detection gas supply pressure, and to avoid the flow back, and to prevent high pressure gas damage anesthesia machine. Also, as a safety feature, we have the quick auto supply. Okay. So here is the gas supply unit. Okay, here the gas inlet without backup oxygen, and here the backup auto supply. Backup auto supply, I don't mean by backup auto supply is the cylinder supply unit. No, it's the connector. There is another connector of the device, on the back side of the device, to connect another like big cylinder, but it's not the pin index cylinder one. Okay, or if I have another oxygen supply source to connect it. Okay, so it's not the cylinder supply. Okay, power switch, flush assembly. Okay, so let's go through the oxygen supply, let's say. Okay, here I have, first I have the particle filter. Or let's say if there is any dust or any small particle to avoid to enter inside the machine. So this is the filter. Usually the diameter of this filter is 0.3 micrometer. Okay. Here I have the check valve, which is non-return valve. Okay. And then I have the pressure sensor to measure or to ensure that I'm in the specific range of pressure of 280 up to 600 kilopascal. Okay, and also I have the pressure gauge, which is in the front of the device. Okay, so this is the oxygen line. Here I have also the pressure switch. The pressure switch that will give me a remedy or alarm if the oxygen pressure going below 220 kilopascal. So if the pressure goes below 220 kilopascal, this switch will give me alarm. Okay, and also here I have the pressure relief valve. Pressure relief valve means that if I connect higher range than the acceptable range of my device, which the maximum is 600 kilopascal. Okay, so if I connect like 700 kilopascal, the exceeded pressure will be relieved from here, from the pressure relief valve. So this, we call it pressure relief valve, to relieve the exceeded pressure. Okay. Okay, if I exceed the pressure of more than 750 exactly, the valve will open and to release the exceeded pressure. Okay? Okay, so what do you think about 5 bar and 4 bar? Is it suitable for the machine element inside or the device item inside? Like if I have pressure sensor and I'm connected, or let's say I have proportional valve and I'm connecting it to the 5 bar or 6 bar of oxygen supply. It will damage, right? So I need some pressure reducer to reduce the pressure to suitable range of my next items of the device. So this 1.5 or 2.5 here, these are pressure regulator to reduce the pressure to 220 kilopascal. So the pressure, let's say it was 500 kilopascal and reduced to 220 kilopascal. Okay?
Yeah, great.
Is it clear? Do you have any question related to the gas inlet?
Yes. Clear.
It's clear. Okay. So, in the anesthesia machine, we are controlling the power and as well the gas flow inside the anesthesia machine by the power switch. So if I switch off the main switch, I will switch off the gas supply to the BFCS and to the AFCS as well. Okay? What's remaining for me only for safety is the auto flush. So I will find a line in the diagram here. So this is the gas inlet block that we described. Okay? Here, just a moment. So we will check it here. Okay. So this is the main switch. It will control the power on and off. Okay. As well the flow of the gases, the AFCS and BFCS. Okay. So if it's switched off, that means I don't have any gas flow in. Okay. But the auto flush, which is number 7 here, it's not related to the power switch. So it's independent from the power switch. It's connected directly to the point after the regulator. So even if the machine is switched off totally, I still can use the auto flush and it will flush the oxygen to the ACG flow. Is that clear?
Yes.
Yeah, if you have any question, yeah?
Clear.
Okay. Okay, so this is the nitrous oxide gas inlet assembly. This is the oxygen gas inlet assembly. In the oxygen gas inlet, we can see the pressure switch. We have it for safety because to ensure that I have sufficient oxygen supply or I have oxygen supply connected to the device. So this pressure switch will give me an alarm if the pressure of oxygen supply is less than 220. If the pressure is less than 220 or 220, yeah. Okay. Smooth. If the machine, if the pressure is less than 220 kilopascal, this will generate an alarm. Okay. I don't have any pressure switch in the nitrous oxide, for example, or in the air supply. Okay, and this is backup oxygen gas inlet, which is in the rear of the device as well. So this is different than the cylinder connector, which is here. Okay. Okay, filter, pressure sensor, pressure gauge, one-way valve, pressure switch, relief valve, and pressure regulator. Okay, this is the yoke. This is the yoke, which is the cylinder, the E-type cylinder or pin index cylinder mount. Okay, this is part of the PN kit, the sealing gear of the washer. Okay, and this is the pressure sensor, which is this one. Okay, or this is the pressure regulator, sorry. Okay, so this is the pressure gauge, and this is the pressure sensor. The pressure gauge of the cylinder in A9 is different than the pressure gauge in the A7. Okay, in the A7, the output pressure gauge of the cylinder is 400 kilopascal in the A7. Okay, and for the A9 or A8 equals 360 kilopascal.
Below.
Do you know why?
I don't know.
This is the pressure regulator of the cylinder, which given you this one, and this one is non-return valve. This is the pressure gauge to see it in the front of the device. But anyone knows why they decrease the adjusted pressure limit? Or anyone can guess?
Maybe because of the different breathing systems, using the bellows in the A7.
Not exactly. Actually, because sometimes they encounter some user forget to close the cylinder. Okay, so they try to decrease the pressure as much as they can, because if they forget to close the cylinder, automatically the device will get the gas flow from the highest pressure. For example, if the water supply is 3.9 and the machine, the cylinder supply is 400, so the device will get the gas from the 400 one. So it will consume the complete cylinder. Okay, instead of working by the pipeline, it will work from the cylinder and consume the complete oxygen cylinder. So they try to decrease the pressure to the minimum possible limit, which is 3.6 bar or 360 kilopascal. Okay, so sometimes the user will forget to switch off the cylinder. In that case, the machine will consume the cylinder pressure. So that's why they decrease the output from cylinder, so that they will make sure that the wall supply will be higher than the cylinder pressure, so the machine will consume from the wall, not from the cylinder. Is it clear?
Yes, but that's not the case in the A7.
Sorry?
In the A7.
Yeah, for A7.
I'm talking about the A7. That's not the case in the A7.
Yeah, for the A7 it's 400. 400 kilopascal. But for the A9, A8, 360. Maybe the newer version of the A7, yeah, the new A5 and new A7 is 360. Also. But old water, old A7 is 400 kilopascal. They decrease it to 360. And by the way, I have submitted the requirement to decrease it more, but I think their capability is to maximum decrease it up to 360. This is their design. Because I found some poor hospital or some remote area hospital, even the pipeline pressure is decreasing below 350 or below 300 as well. And we know our operation age is from 280 up to 6. So 290 is fair for us to work on the machine. So I try to decrease the pressure as much as we can, but I think this is design issue. They cannot decrease the pressure than 360 kilopascal.
Number 60 PSI.
Clear? Okay.
Yeah, it's clear.
Yeah. So this is the coded bill index. So they cannot do like place the nitrous oxide in the air bill index or place the oxygen in the air bill index. So it's different coded.
Different mounting.
Okay. And this is the output, 360 kilopascal or 0.36 megapascal. Okay, this is the power switch. The power switch can control the flow of air and oxygen. As you see here, the air inlet and oxygen inlet. And this is the air outlet, oxygen outlet. Okay, so now it's switched off, so there is no outlet. Once I switch on, I will link this outlet to the BFCS and EFCS, so I will have a flow of oxygen and air supply inside. Okay, power switch gas outlet connect to BFCS, and from BFCS I can get aligned to the EFCS as well. This point is clear?
It's clear.
So this is providing the power to the device as well, the gas supply, the air and auto outlet. Okay. And this is the auto flush. The auto flush is connected directly after the pressure regulator of oxygen to the ACGO. Okay. To the ACGO, whether it's connected to the breathing system. Okay. It will give the gas to the breathing system, to the breathing circuit, to the patient, or otherwise it has the ACGO direct output, so it will give to the ACGO circuit. Okay, this is the auto flush flow rate from 35 liter up to 50 liter per minute. Auto flush can be used without valve for safety. Okay, so let's return back to this slide. So this is mechanical switch as well, or electromechanical switch, let's say. So once this switch is switched on, and suddenly there is a power shutdown of the machine, am I able to use the BFCS or no? It's switched on already, but there is no electricity.
I think you can, because I think it's used mechanically.
Yes, you're right. So if it's switched on, okay, and suddenly there is electricity issue of the hospital and my battery is fully depleted, since it's switched on, so it's linked the gas flow, so I can use the BFCS.
Yeah, this one is mechanical.
Okay, I can use the BFCS and work manual to continue the surgery, for example. Or until find another backup device. Okay. So here for the gas inlet block. Is there any question?
Could you please repeat the question?
Is there any question related to the gas inlet block?
Mapi touch. Busy.
Do you have any question?
Tomorrow, inshallah.
Fine.
No, it's fine.
Okay.
Sometimes connect, sometimes not.
So here's the fresh gas system function. The main function is control gas flow and gas mixing, and also ensure the O2 is over 25%, and anesthesia delivery. This is the main function of the fresh gas flow system. Okay. Ensure the O2 over 25%, because in case if I'm connecting the nitrous oxide, for example, the ratio should be 1 to 3, so 25 to 75. Okay. by seeing this, it's complicated for the EVAP or the electron vaporizer, okay? But this block or this vaporizer base, it's one assembly. So if you have any problem with these valves of the vaporizer, you will replace the complete vaporizer base assembly. Okay, so you cannot order any of these valves separately. The only orderable one is the pressure regulator. We'll go through it, but let's present the AFCS first. Okay, this is the AFCS and this is the DFCS. In the AFCS, what we will find? We will find this filter, okay, for particle filter, and once you find any filter before one valve or before one sensor, what's the main purpose of this? Do you know? Generally in the block diagram. If you find any filter before any sensor or before any valve, let's say, what's the main purpose of this?
To protect the valve or the sensor.
To protect the solenoid
of the pneumatic moisture.
Yes, yes, to protect it, and also one more thing, to smooth the flow which is going to the sensor in case if the flow is going to the sensor, to smooth the flow, to make it laminar instead of turbulent flow, okay, for more accurate measurement. Clear? So actually this filter, yeah. Okay. So this filter is like a tank or reservoir. Okay. So the flow here, let's say it's turbulent flow, and once it flow to the tank and again get a flow, it will be smooth flow. So, okay, it will protect the valve. Also, it will smooth the flow to the valve or to the sensor. Okay. So, in here, we will have the filter. After that, this is for the balanced gas line of the AFCS. Balanced gas, what do I mean by balanced gas? Air or nitrous oxide. Okay? And here is the oxygen line. So, for sure I will select the oxygen, okay, and I will select other balanced gas. So I will activate the other balanced gas by this valve. Okay, so I will select, for example, the air, okay, then it will go to the proportional valve. In the proportional valve, once the doctor controls the air flow, this proportional valve will give the flow to the balanced gas flow sensor. Similar with the oxygen. Okay, oxygen is selected already, and here I have the non-return valve, then I have the proportional valve of oxygen, and then I have the flow sensor of oxygen flow sensor. These flow sensors are KSI flow sensor, heated wire flow sensor, inside the AFCS assembly. Okay, and at the end I have the mixed gas flow sensor or total flow sensor. Okay, so this line for the balanced gas, whether it's air or nitrous oxide, and the nitrous oxide to oxygen ratio will be controlled by the AFCS control board. I don't have SORC similar to the old devices. Okay, and this is the oxygen line, this is the oxygen flow sensor, and this is the balanced gas flow sensor, and here is the mixed gas flow sensor, let's say, or total flow sensor we are seeing. So is that clear?
Yes, it's clear.
Yeah? Okay. And here is the DFCS. Okay, so this valve, if I actuate the BFCS, so in general it's normally closed, let's say. Okay, so I will open the AFCS. Okay, then I will select, this is the resistance for the air and oxygen potentiometer. Okay, I have already the one-way valve for the air and oxygen, okay? And I have the potentiometer of the air and potentiometer of oxygen, right? And this one is the total flow meter tube. This is the one. They have the flow rate. Okay? Up to 15 or up to 10 liter per minute. Is that clear?
Yes.
Yeah. So this is the DFCS and this is the AFCS. Okay? And this pressure sensor, you are asking about the pressure sensor, this one. This one is only to ensure that the pressure inside the EFCS is in normal range. In case if there is any abnormal pressure measurement inside the AFCS will be failure and automatically the BFCS will be bad prone. Okay, so this is the electronic flow control system. In case if there is any failure of it, automatically the system will generate EFCS failure and open the BFCS assembly to control the potentiometer flow of oxygen and air. Is that clear, guys?
Seems.
Yes. Okay. So the gas now is leaving the EFCS or PFCS, or let's say in the PFCS. The gas is leaving and going to the vaporizer or to the electron vaporizer side. Okay, let's go to that. Okay. So the gas is leaving the AFCS and going to the vaporizer side. Here is the gas inlet of the vaporizer. And here is the outlet of the vaporizer, which is going to the ACGO after that. I mean that the mixing process will happen here in the AFCS, then this gas will go to the vaporizer, okay, taking the concentration of the anesthetic agent and return back to the ACGO. So let's go to the vaporizer side now. Okay. Okay. So the most important thing, since this one is completely replaceable, even if you have problem with the vaporizer, the only thing that you can do is to check the pressure regulator. This has to be 150 kilopascal. Okay. The other thing, you can just do the injector valve calibration. Okay. And some more cases we'll go to it later. Some software upgrades. Okay, it might be the malfunction of the vaporizer due to the software. Mainly if the software is less than 1.16. So if you get vaporizer failure, it might be related to the software. Later on we can see some cases. Okay, so this is dry gas pressure regulator. It has to regulate the pressure to 150 kilopascal. Okay, so let's follow the line. Firstly, I'm selecting which vaporizer I want to use, the vaporizer EVAP 1 or EVAP 2. Okay, so this valve with this one is this we call it mechanical vaporizer lock system. Okay, so this one with this one, and the other one with the EVAP 2. Okay, we call this is mechanical lock system for the vaporizer. What do I mean by mechanical lock? So if I'm selecting the vaporizer 1 or EVAP 1, okay, it has sevoflurane, for example. Okay, so this is the selected one. I cannot remove it out from the device, but I can remove the other one. Okay, because it's not locked. Once I look this one will be unlocked. This point is clear? Yeah? Okay, so let's say that this one is the selected vaporizer number 1 or EVAP 1. Okay, so once you select the vaporizer by mechanical lock,
This guy calling
and you are using the EVAP 1, this valve,
we are not here. Yeah,
electronic valve will
next
control
any
the
problem,
pneumatic
this
valve.
one guy will come.
To let them
Open
open.
ticket, next this guy will
To
come.
let the inlet gas go to the vaporizer here. Okay, so this is the fresh gas which comes from the
Tell the name.
We follow it like this. Okay, and then we take a concentration from here and then go back
Follow up this your prometry.
to the outlet.
Huh? 900.
Is it complicated or what?
Tell him to come today before 6, otherwise we will complain STC.
Guys, are you with me?
No, this one customers are only coming.
It started to be complicated.
Yeah, yes.
Are you with me?
Oh, yeah, I'm okay.
900.
Okay.
Yes,
So,
we are with you.
Yeah. One more thing. Okay. So it's electron vaporizer. Electron vaporizer, that means I have injector. Okay. So I will inject the concentration inside this tank. Okay. So here is the drive gas pressure regulator. So I'm taking direct line from oxygen, from the oxygen supply. After the pressure regulator of the oxygen, I'm taking line directly to the oxygen. This pressure regulator has regulated pressure to 150 kilopascal, and now I'm going inside the vaporizer one, which is the selected one, like this. Okay. Here they already insert the agent. Okay. So this area will be drive gas. Okay. So the drive gas will push the anesthetic agent concentration to this tank. It will just push the anesthetic agent. So it will inject the anesthetic agent to this tank. Okay? And after the injection, it will leave and go to the AJSS again. So it's similar to the injector of your car.
Can you please repeat the last point?
The last
Because I was
point.
kind of lost it. Yeah.
Okay. 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 Here we are taking direct line from drive gas, which is oxygen, and we are regulating the pressure to 150 kilopascal. Okay. I already selected this vaporizer, the EVAP 1. Okay. So now I want to inject the anesthetic agent to this tank to mix up with the fresh gas and then gas outlet to the breathing circuit. Okay? So here is the medication, and here the regulated pressure is going inside from here. Okay? Then it will go inside to this area. It's just going inside to inject the anesthetic agent. We'll inject the anesthetic agent from here to here. And then the fresh gas flow will pass, take the anesthetic agent, and go again to the breathing circuit. Okay, so what about the drive gas which is going inside the vaporizer? It will leave again to the AJSS assembly. Because I will show you something, yeah. Here, we have drive gas in and drive gas out. Okay, and we have fresh gas in and the fresh gas out. So drive gas in, the drive gas will go inside the divisor jar to inject. Okay, so the drive gas will be from here to inject the anesthetic agent to here only. Okay, and then the fresh gas will come from here. Okay,
yeah, and we'll take the fresh gas mixed with the air with anesthetic agent. Okay? Is this clear?
Yes, it's clear.
I have one line in for the drive gas, and the other line is for the fresh gas. So this line is for the drive gas, the blue one, okay, and the other line is for the outlet of drive gas, which is going to the HSS again. Okay, so after injecting the anesthetic agent, the drive gas will escape again to the HSS, and here I have the anesthetic agent after it's injected by the drive gas to the tank. Then I have the fresh gas will pass by the tank to get the concentration, and again will leave the vaporizer to the circuit. Is it clear now?
Clear. Maybe. Loud and clear.
This is for the EVAP 1. EVAP 2 will be similar, okay, only the distribution of the valve. But also I have these two valves, this one and this one. This one we call it bypass valve. So in case if they don't want to use the vaporizer, okay, this valve will be open. So directly the fresh gas will come and escape this area and continue only fresh gas without anesthetic agent.
But it will alarm.
Is it clear? For this assembly or replacement, you will replace the complete vaporizer base or the complete vaporizer. So you are not going to interact physically with these valves. Once you have any problem with the vaporizer base, you will replace the complete base. Once you have any problem with the vaporizer, you will just do the pressure regulator check, and you will follow the step of injector calibration. Once passed, otherwise you have to replace the complete vaporizer assembly.
So we can only replace the pressure regulator, right? Alone.
You can only replace the pressure regulator, yeah, the pressure regulator, and there is one electrical connection. We'll get it in the case sharing. So this one, okay, this is the vaporizer electrical connection to the there is in the device, in the manifold of the vaporizer, there is board called vaporizer base connector board. Okay, that board can be replaceable, which will plug to this port. This is in it will be in the vaporizer manifold. That port can be replaced. We'll go to the case sharing later and show you some cases.
If we will replace that one, it will need calibration.
Sorry?
If we will replace that board for the vaporizer, it
No,
will
no,
need
no,
calibration
no,
or no need?
No, it's just electrical connection, that's it.
Okay.
Okay, so is it clear or you need me to demonstrate it again? You know, it's a matter of look. So this is the mechanical lock, which vaporizer I'm working in. Exclude the other one. Okay, and then I have two lines of gases. One is the dry gas and the other one is the fresh gas. Okay, what's the usage of the dry gas? It's only to inject the anesthetic agent. The doctor has the sevoflurane quick fill, for example, and he already filled the liquid here. Okay, now the dry gas will just push this liquid and go to the tank. Okay, then the fresh gas it's already exit from the EFCS and it will pass to this tank to take the concentration and leave this portion to the preheating circuit. That's it. For this valve, it's only bypass valve in case if they don't want to use the vaporizer, or if in case if there is no vaporizer in the device. Like for example, they are using only to maintain the oxygenation, and they are not using any anesthetic agent, inhalation anesthetic agent. They are using some drugs or something. So they don't want to use the vaporizer. So this valve will be open, and directly it will come from here to the safety. We'll neglect this part completely. Is it fine?
You will apply with this?
Yes, engineer, I have one question, please, regarding this vaporizer.
Yes,
because we have a problem here before. This doctor is complaining us that their setting is 1.5%.
Yeah, what's the problem?
Their setting is 1.5%.
Yeah.
But they are got only 0.5%.
Okay.
And they are get only 0.5 only. Then I just told the...
So in that case, you have...
Is there any calibration for the vaporizer?
It's not calibration, there is the calibration of the injector of the vaporizer.
Oh.
Vaporizer injector calibration. I want to ask you a question. The device software version for this one.
I just...
Or did you try with other vaporizers?
Since we installed this A9, we did not still update the software version. So you promised us that you...
And he did. Last week Sammy was there and he did some upgrades.
Okay, but we are in the other area. We are in the EJH Alma Hukuk.
Okay. Yeah, so did you try to swap or to cross-check with other vaporizer and similar phenomena happen?
Yeah, we did not try to swap the vaporizer. What I told the doctor, just replace the water trap. Just replace the water trap, I told him.
Might be related to the agent fuel.
Yes, maybe.
There's many causes. Maybe you have to calibrate the injector of the vaporizer, or maybe you have to check the drive gas if it's sufficient and you are able to reach this pressure. Okay. And the other thing is to calibrate the vaporizer injector.
Okay.
Other thing, if the software version is less than 1.16, you have to upgrade it.
Yeah, you told me before that you will upgrade the version of the software.
Yeah. So there's many reasons behind this.
Okay.
So we can contact for this later, or you can contact them and then I will contact you as well.
But right now he don't have any complaint right now. He don't have any complaint for his doctor.
Maybe related to excessive prison.
Yes.
The anesthetic agent fuel, maybe.
Maybe.
Yeah. So this is the ACGO. Okay. So now the inlet completed, the part completed, and the FCS or BFCS completed, and we already take the concentration from the other, and now we are continually to the ACGO, okay, because all the gases will be in the ACGO, whether they decide to open the ACGO direct brief or to the patient. Okay, so now the gas will, let's say they are going through to the breathing system. So in here I have the AGN, the anesthetic gas end, okay, and also I have the auto flush connected to the ACGO. So the ACGO is like interface before connecting to the patient, whether it's going to the breathing circuit or whether it's going to direct breath. But all the gases will be in the ACGO assembly. Okay? So this is the AG sampling end, which already taken from the no, sorry.
Good afternoon.
Okay, this is the AG sampling end, which already taken from the anesthetic gas. Okay, from the vaporizer, and it's going to here. Okay, and this is the breaking circuit connector, and this is the fresh gas inlet. No, this is the AG sampling end.
في شغل بس مدام هذا في فرمكم. You fixed before, you check.
So this is the fresh gas connector. Fresh gas means after the vaporizer, after the gases or the fresh gas leaves the vaporizer, it will go to this area from this inlet, and this one will give the gases to the breathing system if they select the breathing system or breathing circuit, okay? Or if they select ACG port, it will give the gases through this port, okay? Here is the AG sampling in and AG sampling out. What does it mean, AG sampling in? You know, the external AG module. Okay, the external AG module will return the gas back to the breathing system, right? Because we have the sample gas return, right? Okay? Is that right? Are you with me, guys?
Yeah, that's right.
Yes.
Yeah. Yeah, so this is the AG sampling in, which is coming from the AG sample return, okay? And then this is the AG sampling out that will be analyzed by the internal AG module. Okay, so in case of prediction, that's why I told you, there will be a comparison between the external and internal. So both are connected to each other to compare and to adjust the percentage or the parameter in the ECA, for example. Clear? Okay. So, and this one is the relief valve, 11 kilopascal, which is this one, actually. Okay. So in case if there is a pressure of more than 11 kilopascal, this one will open and release the exceeded pressure to protect the ECG host simply. Clear? Yes, clear. Okay. Okay, so this is the most important part, which is the anesthesia ventilator. Okay. This completely, we call it in the A9 as inspiratory valve assembly. This one, inspiration valve assembly. Okay. Why we call it inspiration valve assembly? Okay. Because in the A9, the main difference between A9 and the A7 in the ventilator assembly or ventilator block diagram is that in the A9, the expiratory valve can be removed with the breathing circuit, right? Recently, we have a quality plan to replace the expiratory valve, right? And you are able to remove this expiratory valve from the breathing circuit assembly. Am I right, guys? Yes? Hello?
Yes, engineer.
Yes, we are with you.
Yes. Okay. So, here the drive gas will come. Drive gas will come to the inspiratory port and to the PEEP port as well. Okay. Here is the filter. This filter will, it's particle filter and bacterial filter as well, and also to smooth the flow. And here I have the pressure regulator of the drive gas, which is regulate the pressure to 150 kilopascal. Okay. Then I have the inspiratory proportional valve and internal inspiratory flow sensor. So this is the TSI flow sensor. So So this is my benchmark during the calibration process of the flow sensor. This one. Is that fine, guys?
Yes. Yes.
Okay. Okay. So, and what about the beep side? Here, number 10.6, here's filter, okay? And number 10.6, we call it beep safety valve. Okay? Here is the pressure switch. It will give alarm once I reach 125 kilopascal. This will give alarm that drive gas supply low. Okay? And here is the proportional valve, or we call it safety valve, the beep valve. Sorry. This is the beep valve. Okay? So what will happen during the inspiration process? Let's say, during the inspiration process, the gas will go from here and going to the volume exchanger. Okay? But I want to make sure that the gas will not escape from the volume exchanger to the expiration side. How to make sure? So during the inspiration, the beep limit which going to the expiratory valve should equal to bound. Is that clear?
Yes.
Yeah, this is during the inspiration phase. Okay? So, what about, this is in the inspiration phase. The inspiratory gas will go from here through the proportional valve, or through the inspiration proportional valve, then to the PSI flow sensor inside, then to the non-return valve, and this one is like a relief valve of 110 centimeter H2O, or
ano bang nagpo-control nung sa ventilation, hindi na makita. Ano ba nagpo-control dito dyan sa pag-ventilation mode?
or 11 kilo.
Ano ba yung nagpo-control ng volume, tidal volume?
So this is like a protector. If the inspiratory line of the drive gas or ventilator inspiration line has a pressure of more than 11 kilopascal, it will release the exceeded pressure. Okay? Then the gas will go to the volume exchanger. I don't want the gas to escape from the volume exchanger back to the beep line. So there will be a pressure here equal to the bow limit in the inspiration phase. I hope it's clear, right? Do you need me to repeat it again?
Yes.
Yeah?
Yes, please.
You need me to repeat it, okay. Okay.
Makuha yung explanation.
So, we are in the drive gas, or let's say in the ventilator assembly. We agreed that we call this one in the A9 inspiratory valve assembly.
Oh my god, 4 hours, 1 minute, 36 seconds.
The expiration valve, which is this one, is a part of the breathing system. Okay, this is the expiratory valve. Okay, so the drive gas will come from here. First thing, I want to confirm that the drive gas is within pressure of
Control ventilation.
150 kilopascal.
Gas beep.
Okay. Then I'm going to the inspiratory proportional valve. This one.
चलो ठीक है.
चलो वो शेक इंस्पायर्ड ऐसा भी
150 kilo.
Proportional valve. Okay. Let's say I will open the flow. Okay. Now I will measure the flow by this sensor, which is internal flow sensor.
क्या खाया था सुबह?
TSI flow sensors?
Yes. This is the TSI one. Yeah. This is our benchmark during
तो
the
ये बोला था ना
calculation of
सलाड
flow.
वगैरह खा लेना.
Okay. So now the gas is going through the non-return valve. Okay. And here I have safety relief valve. So in case the pressure reach more than 11 kilopascal, the exceeded pressure will be relieved from here. Okay. Then I'm going to the volume exchanger. I know after some time someone will ask me about it. But let's go for the inspiration process. Okay. So now the gas is going to the volume exchanger. I don't want the gas to return back to the PEEP line. So what should I do? I have to make the pressure here equal to the airway pressure. So the PEEP proportional valve will work and giving me the airway pressure below the diaphragm and close the expiratory valve to this limit of the airway pressure. Let's say it's 40 millibar. What to do? Is this clear? This one?
Yeah, so which are the same number, there is no flow between two sides.
What?
You mean that?
What do you mean? What do you mean?
When we have two gases and there is two, both of them are single pressure, right? So there is no flow between them. So there is same pressure. There is no such a certification.
Okay, this is the expiratory valve, right? And this is the expiratory valve diaphragm. Okay, now the gas is going from here. Okay, and also it will go from here. But this is proportional valve is closed now. So consider all the gas going from here. Right, because this proportional valve is closed. It's a jet. Okay, so I don't have any flow in here. Okay, but the thing is, this gas will go to the volume exchanger, and they want to make sure that this gas will not go back from this line, because this line is open from this gas. Okay, so what I will do, I will open the PEEP valve and give a pressure equal to the pressure inside, which is 40 millibar, depending on the doctor's setting, to avoid any back pressure from here.
backflow.
This is during the inspiration phase. Is it clear?
Yes.
Yeah, that's clear. To avoid the backflow.
Yeah.
The pressure.
Yeah. Okay. So this one, we call it PEEP safety valve. But why we call it PEEP safety valve? When I'm saying safety valve, you think that this patient safety valve. Actually, it's patient safety valve, but indirect way. Think about it, guys. What's the purpose of this safety valve or PEEP safety valve here?
To protect the patient from the high peak or low peak.
Very good, yes. It's protect the patient from the high peak or low peak, or from the high pressure. Why? Imagine that this valve is open and it's giving me a pressure in here up to 40 millibar. Imagine that there is a problem or there is a failure of this valve. Okay? So by keep compressing this, I will affect the patient, I will pressurize the patient, right? Over than the required limit, which is 40 millibar. Right? So at that time, this safety valve will close the flow completely from this line. Is it clear, guys, or you have some confusion?
It's clear, it's clear, sir. Yeah, it's clear.
It's clear, huh?
Yes.
Do you have any concern? Okay.
Ahmed? कुछ नहीं बैठा था बीच में
So,
ऊपर तो आगे तो
Yes, engineer, what is the maximum, minimum, and maximum pressure that detect this safety valve?
बस ठीक ठाक
That it will automatically close. What is
yeah,
the pressure? What is the pressure?
वो काम खत्म क्यों चल रहा है
The maximum pressure.
What's the
For example,
maximum pressure?
more than 40 millibar, so it will automatically close this one. What your setting is
no,
40
no, no, actually,
millibar.
Yeah.
Your setting is 40
Yeah,
millibar.
yes,
Then it
yes,
will
yes, yes.
the
My setting is 40 millibar.
that it will
Okay?
yes.
So, it's not, for example, if I'm reaching 41 millibar, it will not close. But if I'm reaching more than 43,
Okay.
it will directly close this.
Okay. Okay.
So there is some tolerance only.
Tolerance
To
only.
close the flow of the, yeah.
Okay. It depends on the settings of the doctor.
It depends on the setting of the doctor, yeah. Yeah,
Okay.
for sure. Okay. Okay, so now in the respiratory phase, okay, one more thing.
सेल करना है लीड के स्टॉल लगाना है
Imagine that the patient, or there is some blockage or some blockage in this area. Okay, somehow there is a problem. For example, with this valve, with the proportional valve, this proportional valve, and the gas, no more gas coming from here, and no more pushing of a fresh gas close to the patient. Okay, or suddenly the patient has spontaneous breathing. Okay, and he's trying to breathe by himself. So this is emergency valve supporting spontaneous breathing of the patient. Number 18.21. Clear?
Okay.
We call it emergency valve.
Support spontaneous breath?
Support spontaneous breath in case of there is any blockage.
It's like ambient valve?
It's like I will see exactly the pressure limit of this one. It's negative pressure valve. Once the patient tries to inhale by himself and reach the required limit, this valve will open and can suck from the room air. Okay. Okay. So this is the TSI flow sensor, which I refer to in the calibration process. This is the inspiratory proportional valve. This is the pressure regulator of the drive gas. And here is the PEEP safety valve 10.6 and 10.7 the pressure switch. If the pressure of the drive gas reaches below 125, it will give me alarm. Okay, 10.8 the proportional valve, the PEEP proportional valve, and 10.9 is resistance. This resistance is to increase the the PEEP pressure. That's it. It will help to fast reach to the PEEP pressure from this resistance. Okay, or to the setting pressure of bow or PEEP together. So in the inspiration, I have the bow, and the expiration, I have the PEEP. Okay. Okay, here in the block diagram, and this is the actual, this is the PSI flow sensor, this is the PEEP gas inlet, this is the proportional brake valve, and here is the drive gas outlet. Okay, this is the inspiration side, so this is the pressure regulator, and this is the proportional inspiration valve. Okay, this is the pressure switch, which is this one, 10.7. And this is the drive gas out. Okay, this is the PEEP to AGSS. Okay, this is the resistance to harden the pressure of the or the exceeded pressure to go to the AGSS from this side. This is the inspiration gas. Okay, is this clear for you guys?
Yeah, it's clear that engineer.
Yes, it's clear.
Okay, this is the expiratory valve assembly inside the breathing circuit. Different than the Wato. Or Wato on A7, we have the black one, shaped like this, and below there is a diaphragm. That one, the expiratory valve in Wato. Right? But in the A9, the expiratory valve is a part of the breathing circuit.
नहीं कुछ भी नहीं अभी तक वो कह रहे पेपर में
Okay, this is the volume exchanger. The maximum volume of volume exchanger is 1500 ml or 1.5 liter, and it's autoclavable. Okay. So I will repeat this video again, or just to see the to measure the inspiration and expiration phase.
ये तो मिलती है इधर बुकाले से भी मिल सकती है, ऐसी जगह से भी मिल जाती है वो स्मूथ हो जाएगा, स्वीट वाली स्मूथ थोड़ी सी बीच में डालते हैं। हाँ तो फ्रेशनर सा बन जाएगा, थोड़े मिश्री तो इधर पड़ी है काले में नहीं मिलती। तो लीडर कौन करना है? तुमको बोलो कि ये चीज़ और वो दूसरी मिल जाएगी, मिश्री तो कीम से मिल जाएगी और मीठी जो सुबह का वो दूर से मिलेगी
So this is what will happen during the inspiration. The PEEP is open at PEEP limit, okay, and expiration valve closed. Okay, So this PEEP will open at PEEP limit, at the P limit or the bowl limit. Okay. So it will deliver the gas, the dry gas will be here below the diaphragm, and you close this valve at the bowl limit. Okay. Inspiration proportional valve is open. And okay, I have set the tidal volume rate, inspiration to expiration. Okay, drive gas entering the volume exchanger, pushing the fresh gas into the breathing circuit. Okay, so the fresh gas first, it will come directly from the mixer or from the AFCS to the patient. Okay, and after the patient exhales, the gas will come from here and it will be pushed back to the patient for second inspiration phase from the drive gas from here. Okay. Let's see the expiration phase. Yeah. So as I told you, this proportional valve is open and given valve unit to this diaphragm to close the expiration valve. So the gas tries to escape and it's preventing by the expiration valve because there is already a pressure below the diaphragm equal to this pressure. Okay, this is the expiration. The expiration and the expiration PEEP valve will open and PEEP expiratory valve provide PEEP. Okay, so in the expiration, the PEEP will be opened at the PEEP limit. Okay, or will be closed at the PEEP limit. So I keep the patient to exhalate until I maintain the PEEP. For example, 5 millibar PEEP. Okay, whatever exceeded gas, it will escape to the AGSS from here. Okay, is that clear, guys? Yes. Yeah, so the patient is already exhaled from here. Okay, and here I have the PEEP limit, which is 5 millibar, let's say. Okay, so the AGSS will still receiving the gas from the patient until I reach the 5 millibar. Okay. Clear? And this one, relief valve, it will protect the line from the expiratory valve to the AGSS. I don't want to have the pressure in this line. So it will open at the, I think it's around 11 also, yeah? 11 kilopascal. I will make sure about this point, what's the relief pressure of this valve, but it's to protect the line from the expiration to the AGSS. Okay? Clear, so now the inspiration and expiration phase should be clear. Is it?
Yes.
Yeah, so now the patient is already exhaled and now again the inspiration phase will happen. The gas will go from here. Again, I have to set the valve limit and the expiratory valve, and the gas will go through the soda line canister. Okay, these valves are the bypass valve of the soda line canister. Okay, and this 18.18 is the soda line canister. So it will pass to the soda line canister again to the patient. This pressure gauge is the pressure gauge which is available in the breathing circuit. Okay.
Hello. Oh.
Matt, sorry for interrupting you.
Yes.
I just received a service issue from a customer about my machine. Okay. The error is internal AT error. Exit code 02. Okay. Can you explain this this error for the process, but be sure to check.
Can you repeat it?
Yes, just receive service issue of A9 error internal AG error 402.
Yeah, okay, internal AG0. Okay, so what's the software version of this device at first?
Let me check. It's V01.
Sorry? Yeah, V01, I need the complete software information. This is the general, but you can go to the service menu and software information to see the complete software information. Should be now 1 point something or
so you know it was
1.19, 1.20.
And then
And which
one?
which country is this one? First time? This is the newest that you will see, right?
ब्लैक एंड व्हाइट आएगा ब्लैक एंड व्हाइट आएगा कलर नहीं है कलर मेरे पास कलर सिर्फ वो दो है
The new one
आएगा उधर है उधर नहीं आएगा वही क्या
So it is the
कलर उधर है
new
हाँ उधर है
A9.
हाँ वही है ना
Okay, so maybe
इसका
your
WhatsApp पे भेजना
should be with
राजर का
with the internal AG. You can also check that filter already mentioned. If there is any contamination, and double check the software version of this device. Okay. Such error may be
your WhatsApp is there
the worst scenario. We have to change
WhatsApp.
the internal AG module.
your WhatsApp is open
But we need to confirm these steps.
मुझे सेंड कर दो मैं
The
इधर भेज देता हूँ
of the AG module, and the second to make sure about the software.
But when you ask about the software,
Sorry?
when you ask from the software, you need
Planning a case, if the software version is all software, yeah, that is the software. That's why we need to confirm the software version. Right. Good. We have similar case, maybe we can discuss it after the case sharing. So I think there is similar case in this case sharing as well. Okay. So this is the breathing system or the breathing circuit.
नंबर बताइए ना आपका 05 050 050 232
Okay, here we have the bypass valve,
232
and here is the canister, here is the non-return valve,
5231
and here is the pressure gauge. Number 21 is for the oxygen sensor calibration valve. It will open to 21% to calibrate the oxygen at 21%. Okay, and here is the number 18.3 is the oxygen sensor. going to the patient, and also this is in replace the volume exchanger now. So the doctor will just push the bag to get the inspiratory goes to the patient. And here is the expiration. If there is more pressure, it will be released from here to the AGSS as well. Okay, so this is the breathing system interface in the device itself. This is the heater. It will heat up the breathing circuit. Okay, and this is the inspiratory sampling line, expiratory sampling line, which is getting from the inspiration flow sensor and expiration flow sensor. There will be two tubes connected here, or inside the breathing circuit. If you just plug in the breathing circuit, the two tubes from here will go to the sensor interface board. Okay.
I think in the new models for A5 and A7, it's mostly the same, I think.
Same as this one for the new A5 and new A7.
Yeah.
Yeah. But for the old, the sensor was connected directly to the monitor board. We have the DSP and we have the Epson, right?
Yes.
Yeah. Here, this monitor board, nothing connected to it. There is interface port, and this one will be connected directly to the motherboard. Okay, this is the sensor interface port. We have the beep and we have the bow. Okay, and we have the also auxiliary or intrapulmonary pressure sensor. If you have this option. For example, this we have only the beep and the bow, so we don't have the inspiratory, or we don't have the intrapulmonary pressure sensor. So it depends on your device configuration. If you have problem with the sensor interface board, you have to order the proper one. Depend if you have the intrapulmonary pressure or not. Clear?
Is this connected to the main board?
Sorry?
This is connected to the main board?
This one connected. This is in the upper side of the device. No, the main board is in the back side of the main display. This one. Sorry.
Okay.
Yeah, this one. The tubes came from the pressure sensor. The tubes came from the flow sensor. Will be connected to this interface board. Okay, and it's located in the upper part of the instrument door. We'll see it. Maybe I have. Yeah, it will be exactly here. Here it will be this is the three-way valve, for example, and you will find the monitor, the interface board in this area as well. Okay, so the monitor board will be in this area. Below this cover, there will be the monitor board, and it's connected to the motherboard. This is the flow sensor of the EFCS assembly. This is the oxygen and the air. And these are the proportional valve of the EFCS.
So that is engineer, I have a question. If we will replace that board, this monitoring system sensor board adapter, we need calibration?
Yeah.
We need calibration
Yes,
to replace?
For sure, you have to do. You have to do the factory flow calibration and factory pressure calibration.
Okay.
Yes, you have to do.
Okay, engineer.
Okay.
Yes.
Why do we need to do factory calibration? It should calibrate in the factory.
This one?
We order a new board. Yes, it should be calibrated.
He is asking about.
Yeah, this is electronic sensor. This is not this is electronic sensor. That's why we need calibration.
I know.
Sensor. Yeah, so you need to write the sensor AD data to the monitor PCB, because this is different sensor than the one which was connected to the monitor, or different data than the one which was installed before. Okay. So while you are doing the factory calibration, you are registering new AD data to the monitor PCB.
Yes, so it's necessary to do that. Yes.
Yeah, necessary. Yeah, necessary, yes. So, monitoring module, replace the monitoring module, upgrade the latest software, check software version, flow and pressure calibration, oxygen sensor calibration, function test, refer to the PM checklist. Okay, this is the AFCS monitor board, or we call it AFCS control board as well. Function monitor and control flow of fresh gas, provide drive for three-way valve, which switch valve and electromagnet. Okay.
Electromagnet tawag na dun sa ano eh, sensor.
It will be behind the EFCS.
Hindi,
There will be a board. We call it
oxygen sensor na electronic.
EFCS monitor board.
Electromagnet sensor pala yan. Oo. Electromagnet sensor na tawag nila.
Ba't electronic sensor na yan?
Oo, electronic sensor na to.
Parang sa laboratory.
Okay, this is the flow sensor of the AFCS assembly. This is TSI flow sensor as well. In the AFCS, all the sensors are TSI. Okay. Monitor gas flow and feedback signal to AFCS monitoring board inside maintenance, the maintenance door, which will be here. Directly here. These are the two. So this is the AFCS assembly. Behind the AFCS, we will find the AFCS monitor board, or we call it AFCS control board.
AFCS control board.
Okay, and here is the PFCS switchboard. So this switchboard will be connected to the PFCS door. Okay, so once open the door, the BFCS will be triggered. And here this BFCS backlight board. Here the auxiliary flow meter board, the auxiliary AO2. And also we have the auxiliary AO2, and we have also the HFS board as well. This is the auxiliary flow meter backlight board. This is the auxiliary AO2 keyboard, or switch off on button, because there is switch off and switch on. There is a button to switch off and switch on. Mandatory, we need to, if we are doing software upgrade, we have to make sure that the HFNC or auxiliary AO2 is on by this switch. Okay, this is the HFNC monitor board. High flow sensor board for HFNC. Okay, so this is the signal display. It will be in the air O2 flow meter or air O2 HFNC. It will be in the instrument panel. This is the one. It will be here. Okay, and I have the concentration, the flow of oxygen and the flow of air displayed here. Okay, so this is the vaporizer based interface board, or vaporizer based connector board, we call it. Okay, sometimes we encounter some cases recently that vaporizer hardware failure. Okay, or the vaporizer and the system check the vaporizer fail. Okay. While we analyze the log, we find hardware issue in the vaporizer side. Okay, and sometime when they move the vaporizer a little bit or plug it out and plug it in again, it will work. Okay, so in case if you found this issue, this vaporizer connector board has to be replaced.
Still recording.
Okay. So it's electrical connection to the vaporizer.
No, why just recording not like this?
We will see the case together after this presentation. And the connectivity of the HDMI cable. Okay? If it's not connected properly, just fit it properly and then try to restart and do the upgrade again. It will solve this issue.
Khalas, feather is ready to fly.
Okay. Appreciating sensor and valve. Guys, you need one more break or what?
You have to put something like
One more week, I already make my coffee.
For how long? I feel that you are tired, guys.
The content is just too much.
Yeah. Yeah. But how is it? Do you have any concern or something?
With time we grasp the concept, but yeah, the basic
Information, that's it.
Yeah, too much information, yes. It's A9, A8 showing what to do.
There you go.
So we'll have break for like 10 minutes. It's fine for you?
For good. Yeah, I think 10 minutes, it's okay.
Yeah, okay.
Yeah, it's okay, Jimmy.
Yeah, it's okay.
It's coffee time.
Okay. Yes, coffee time. Resume.
Okay. Drive gas system.
There is no guys there.
Okay, engineer, let's resume the thing.
Okay.
It's very nice mic. 700 real.
Oh, Raz market
Real.
is best than
Audio Technica.
Only 7 real.
But 7 real, 3 real.
Okay, so now with the troubleshooting part, zeroing the flow and the pressure sensor. When we have to make zero of the flow and pressure sensor,
incorrect flow calibration is failed. Zero.
when the tidal volume is incorrect, or flow calibration is failed, zero could help and sensor are normal or no. Okay, so the principal three-way valve is linked between the
Zero.
circuit and the sensor adapter board. Three ports on those valves are linked to the circuit, sensor board, and atmosphere. When unit is working, three-way valve link circuit to the sensor. Port 0 means three-way valve will link sensor board to the atmosphere to get the reading and record the monitor and record in the monitor board. So if I'm telling you check the zeroing data, if it's accurate or no, as per the actual range, as per the range in the monitoring menu of the diagnosis page in the service menu. Okay, three-way valve will link this pressure sensor to the atmosphere to do the zeroing. Okay, so once you have problem with the tidal volume, for example, or inaccurate flow calibration, or the flow calibration is failed, try to do zeroing by linking this sensor to the atmosphere through the three-way valve and get the zero data. This might help to solve your problem if the zeroing is passed, and then the tidal volume measurement will be okay, or the flow calibration can pass. That's when you have to do the zeroing to overcome these issues. Is it clear? Because the flow sensor, let's say the expiration and expiration flow sensor are connected to the sensor adapter board. And in the sensor adapter board, we have also the three-way valve. The three-way valve, for during the zeroing process, it will open the sensor to the atmosphere to get the zeroing data, to make zero. This is my zero, okay? You know, if you are moving the device from side to different side, according to the altitude, this pressure sensor, the zeroing data might be changed according to the altitude. So again, you have to do zero to ensure that the zeroing data of the sensor is accurate. This will lead to accurate measurement of the flow and will lead to flow calibration to pass.
So you mean engineer, we need to zeroing place first before we go through the flow sensor calibration.
Is it clear? Yep. Yeah, you can do zeroing. After that, you can do the flow sensor calibration. Okay, but to record the accurate zero data in the interface port or in the monitoring module. Okay, how to do it? You will just go to the service. The password will be 789789, then calibration, then zero sensor. So you can do the zeroing. Okay, and here is the normal range of zero or the normal 0 point. You can confirm this measurement by going to the monitoring menu, and then you can have the zero data, or else we can export the log and read this zero data. Here?
Yeah, engineer.
Okay. Zeroing of the flow meter. Okay, flow meter, I mean in the AFCS, for example. Okay, flow meter reading is not zero without setting. This test is to check if the sensor is broken or not. Principle, rewrite 0 point record of O2 flow sensor, balanced gas flow sensor, and total flow sensor. Okay, so if there is a reading, let's say you are disconnected the gas supply and you still having reading in the sensor. Low reading of the sensor. Okay, that means you have to do zero by doing zeroing of the flow meter. So you'll zero the oxygen flow sensor and you'll zero the balanced gas flow sensor and the total flow sensor as well in the AFCS side. How to do it? To go from the service to the calibration and zero flow meter. Okay, and zeroing auxiliary or O2 and air or HFNC. Flow meter reading is not zero without setting. This test is to check if the sensor is broken or not. Rewrite the 0 point record of the two flow sensor. The two flow sensor of air and oxygen in the auxiliary air oxygen flow meter. The same menu, we have to go to service, calibration, then zeroing the auxiliary air and oxygen. So here, disconnect the O2 and air supply to make sure that I'm in the 0 point and start begin, then zero successful, for example. Zero HFNC similar. Because the machine will be configured with HFNC or auxiliary air auto. Okay, functional test, constant flow test. Check if the flow sensor valve, inspiration valve and P valve work normally or not. Okay. So, okay, I will visit it later. Actually, there was a leakage, but it's not actual leakage. And we solved the problem by doing the constant flow test first to compare that the internal flow sensor reading is different than the external inspiration and expiration flow sensor. Okay. And after that, we did the only calibration of the flow sensor and the problem solved. I will share this case later. Okay, how to make the constant flow test? You just go to the service, diagnosis tool, valve, safety valve, make it on. Okay, and then the B valve, make it high limit, let's say 50 or 100 something, 20 meters to all. Sorry. Okay.
Break.
Hello.
This one break, sir. Break.
Okay. Okay, so you'll make safety valve on and you will make the inspiratory valve
Zoom in,
flow
zoom in,
whatever
zoom in,
flow you
zoom in.
need. Start it from
Da, da,
3,
da, da,
let's
da,
say,
da.
and then increase gradually the flow 3, 5, 10.
May translator ng
And
Chinese
then
yun.
make the beat valve to
Ah, zoom in, zoom in,
250.
zoom in. Ah, zoom in, zoom in.
Then you can see the internal flow sensor, which the PSI one,
Chinese translate.
and compare it with the inspiration flow sensor.
Ano
and
nangyari sa hati
expansion
mo sa
flow
airport?
sensor. If there is a difference
Ha?
of more than 1 liter
Wala
per
pa
minute,
rin. Wala pa rin yung visa niya.
try to do
Ano yung
the
ticket niya?
calibration of the flow sensor.
Kinakancel na.
For example, I said
Parang
200
willing yung
liter,
amo nilang ipa...
20
Wala, hindi na
20
makancel
liter per
yun.
minute.
Ha?
I should see
Maano
it here
lang,
on
wala
the
yun.
inspiratory flow sensor.
Kasi pag cancel
Okay.
yun, kaya nga medyo
That's because I opened the inspiration valve
Kasi
20
pag
liter per
cancel yun,
minute.
24
I
hours.
should
Wala
read
pa
it
rin
on the
online lang
internal
naman
flow
yun.
sensor. After that, I
Baka
will
naman
compare
hindi
the
talaga.
fusion
Matagal lang
with
expire.
these two.
Baka
For
pinanti.
example, 20,
Ha?
here I read
Siguro.
18
Pinanti
and
yung
here I read
visa.
20. That means there's a problem with the
Ikama.
inspiration flow sensor.
Ah, may
So I will
pinanti
do
ikama niya.
calibration.
Matagal na yun.
Whether it pass,
Kisahin niya ikama niya.
it's okay. It will solve the problem. I can make the constant flow test again to confirm that the problem solved. Or otherwise, I will
Dapat
go
galing yung
to
muna ikama.
change the inspiratory flow sensor and the
Yung
clicking set.
malaki yung penalty na kaya...
Is this clear?
Bakit? Akala lang ano lang ba yun? Hindi ba company malaki yan?
Is it clear? Yeah.
Yeah.
Yeah, it's clear, it's clear.
Okay. Functional test of the vaporizer, drive gas, pressure regulator. Okay. When I getting error of vaporizer failure, check if the drive gas pressure is 150 or not. Enter to standby mode, set up service diagnosis tool, vaporizer test, set the drive gas valve status to on. Okay. And then see the drive gas pressure. If it's 150, it's okay.
They should be.
If it's more than the acceptable
What
tolerance,
is hand in the kid?
so you have to change the drive gas
Not hard.
pressure regulator of the vaporizer. But first try to upgrade software to more than 1.60.
1.60.
If your software is below this software. It's fine because you confirm that there's problem with the drive gas pressure regulator
Ano ba yung software ng A9 natin?
of the vaporizer.
Panakuha yung software niya.
Clear?
Yes.
Yes, clear.
Okay. AG fuel pump rate, check. When the AG airway occluded, or AG zero failure, or as per your case, the internal AG error 02, first time. Hello?
Yes, yes.
Yes.
Walaikum
If you have internal AG error 02,
Yeah.
You want to do?
by the way, if you are getting AG airway occluded, that's mean the external one. If you are getting internal before the AG, that's mean the internal one. So without anything written before the AG, that mean the external one. But if this internal AG module, you will find this word internal AG module.
It's our
Error.
long time.
I mean the machine will not write external AG. So without internal, that's mean external.
Because I cannot
Okay. If the internal AG module.
You want to do exercise, go to
Okay. Check the pump rate to see if there is airway block. Install the AG module and link all tube. Choose manual mode
No,
and
this PD.
standby. Okay. Choose setup, service, data monitor, AG. Check the pump rate if it's 120 milliliter per minute. If not, check the airway step by step. Okay. Alarm start with internal. This is the internal AG alarm. Otherwise, the external AG alarm. Okay, internal AG reading on the left and external AG reading on the right. So we can do this step to troubleshoot this internal AG error 02.
Okay, but do you know they just
Yeah.
for me they just replace the sample line and the water trap and
The problem solved.
yeah.
Yeah, okay. Okay. That means there is a blockage. Yeah. There's a blockage and we are not able to reach 120 milliliter per minute.
So this because they're using a water trap for a long time, for example.
Yeah, yes. For a long time water.
Weekly or monthly.
Yes. Or excessive water on the water trap side, and they didn't suck this water. Yeah. So something is a blockage, the pump flow, it's not reaching 120 milliliter per minute. Okay. So step analyzing the problem. Make sure there is really malfunction of the device. Okay. Begin with the simplest test. Get more information through special tools or our service like the diagnosis menu, the valve test tool. Analyzing based on the principle, record the phenomenon and return the valuable data in time. So if you had problem, first make sure that there is a problem, it's not user mistake, for example, and begin with the simplest test. You can go through the constant flow test, you can go through the constant pressure test, you can do, if you identify there's a problem with the flow sensor, for example, you can just do the calibration, it might solve the problem. If you are not solving the problem, you can return the video and photo to the CS, and then if the CS is not solving the problem, you can raise it or can escalate it to the HQ or to the RTS. Okay, but we need valuable data or clear information about the exact phenomenon of your problem. Okay. For example, here we have leakage of 200 to 1000 milliliter per minute. Okay, if the leakage is in middle range, let's say the leakage is from 200 to 300, so maybe you can just recheck and the problem will be solved. Okay, if no, suggest check O-ring on the bypass assembly, which is the part of the PDM kit. Clean it. If the leak only happened in the manual test, change the silicone manual bag, the breathing bag, please. If the problem is only in the manual test, most probably it's due to the breathing bag. And if it's within the range of 200 to 300, if you restart the test and again you're still having this problem, most probably you have to check the O-ring of the bypass assembly. Let's see this video. No, this leakage was only from the connectivity of the circuit, breathing tube. Okay. So if you have problem with the leakage, try to minimize the system to check. What do I mean by minimize the system? I mean you can just make a connection between the inspiration to expiration. Okay. And you can remove the oxygen sensor. If you have oxygen sensor, you can just remove it with its space, okay, to eliminate the oxygen sensor side with the O-ring, okay. And then you can also remove the aging module completely with the sample gas return, okay. But don't remove the aging module without the sample gas return, because the sample gas return will be open and it will let the air goes inside the breathing circuit. So there will be a leakage source. So if you remove the aging module, you have to remove the aging module together with the sample gas return. Okay? And also you are able to remove the canister to eliminate the leakage as much as you can. So remove the canister, but this handle has to be closed to trigger the micro switch, because otherwise the machine will give you a message without CO2 absorber cannot continue the test. So if you remove the canister, you just close this handle to trigger the auto switch, the micro switch, sorry, and do the leakage test. By this method, you can like eliminate the causage of the leakage, and you can identify it later. Then start to return the part by part, like oxygen sensor and the aging module and the canister. This is the best way to find the leakage point. Okay. Since we are in the case sharing, so let's go to the case sharing slide. It's much better than this one. Okay, so this is these are some technical news with some case sharing also. So this is the first technical news. We already launched the new A9 platform. We can recognize them by the serial number. Okay, for example, the old A8 is started with AG9 serial number, and for the new A8 is started with the FX6. Okay, and also you can recognize for the A9, the new A9 is started with FX7, and the old A9 is started with AG4. Okay, so other way to recognize by seeing this VGA board, that means that this is old platform. For the new platform, you will find the HDMI connector here. Okay, the new platform has a new hardware that is not compatible with the old platform. Okay, in the new platform also we have a new feature called Anesthesia. You know Anesthesia, guys? What is it?
No.
Anesthesia that you are able to connect the pump, okay, the syringe pump, to the anesthesia machine, okay, and control the dose from the anesthesia machine. Okay, so it will be like anesthesia workstation. So instead of controlling the dose of the pump directly in the pump side, the doctor can control the dose of the pump and of the anesthesia machine from the anesthesia machine display. Okay, so whether you have old platform and you need to upgrade it to the new platform, there is upgrade kit part number. It's mentioned in the technical news 24005. I will open it after the case sharing to show it to you. For Russia and Brazil, this feature is not available in the new platform. Okay. Okay, now we are returned back to the old platform. The latest software version of the old platform is 1.21.02. Okay. What's the main change of the software? Optimize occasional black screen problem. Okay, so if you are getting black screen problem, the best way is to solve it. If you don't have the newest software, you will just switch off and on the machine back to work. Okay, but to eliminate this problem completely, you have to upgrade the software to 1.21.02 for the old anesthesia old platform. Okay, and they add turn on off option in the function configuration menu of service. Okay, and also
why you make exercise? Why no need?
Ratio. Turn to 2.1 and so before we cannot change this IE ratio default configuration, which is 2.1, 2 to 1, 2 inspiration to 1 expiration. Now in the new platform we are able to change the default setting. I mean, when you switch on the machine, you will find the default value of the IE ratio 2 to 1. You can change the default value in the new software. 1.21.02.
Who's this guy?
Okay.
Yeah, great.
So, yeah. Okay. In the past half year, most of customer reported leakage test fail or not pass occasionally. Some found the expiratory valve calibration failed and show error code 11. Manual leakage test not pass occasionally and leakage around 200 to 300 or 2 pass. The root reason is disposable 3 liter manual too soft and its compliance too high. Too soft, not too software. Too soft and its compliance too high. Okay, it will cause the flow compensation from EFCS after pressure keeps stable at 20 centimeter H2O during the manual leakage test. Then machine will miscalculate the flow compensation as the leakage. Okay, so if you are getting a leakage of 200 to 300 ml and sometimes you are getting error code of 11, third thing, think about the manual bag. Manual bag, maybe it's too soft, so the detection of its compliance is not accurate, so the machine cannot compensate the leakage and there will be a leakage exist in the manual leakage test. Okay, auto leakage test fail occasionally and manual pass. Expiration valve calibration failure code 11. So here the manual leakage test not pass and the auto is pass, and here the auto leakage test is fail and manual test is pass, and still I'm getting error failure code 11. Root cause is expiration valve membrane inside breathing circuit. Okay, unit is too hard. Most of failure happened with the machine produced before 29 of April 2022. So that's why we have the quality plan to solve such leakage problem related to the expiration valve. You know about the quality plan, guys? Hello?
Come again?
Come again, engineer?
Yes. You know about the recent quality plan to solve this historical problem of leakage due to expiration valve, for example. The quality plan was to
upgrade the software.
Sorry?
To upgrade the software.
To upgrade the software, and there's some part to be changed, like expiratory valve, and it depends on the unit. It depends on the inventory. Some unit had the part to be changed, and some unit only software upgrade. So the parts is expiratory valve, and also the sealing of the yoke of the cylinder, and also sealing of the vaporizer.
Superstitious.
So you mean, engineer, the machine that produced during April 2022, you mean? Because we received...
Before that, yeah.
Before? Because we received 2023?
Yeah, I think you already part of the quality plan.
Oh,
so,
okay.
Yeah, so I think you received the part as well.
Okay.
Yeah. So, dealer reported abnormal operation of A9 evap operation during use with the patient during the first PM of being used. An issue in the evap during the self-test of anesthesia machine showing evap hardware error. After troubleshooting was done, it was detected that the root cause of the issue is the evap connector on the electronic vaporizer base. Okay? So, once you face similar issue, which I will show it to you in the next slide, you have to replace the evap base connector port. This is the part number. So, this is the issue, like sevofluorine vaporizer communication stop, or isofluorine vaporizer communication stop, and also during the device test or system check, the vaporizer failed. Okay. Sometimes if you unplug and plug it back, it will pass. We find there's a problem with the connector board, the vaporizer base connector board, and they improve the material of this vaporizer base connector board. So if you have this problem, you can order this vaporizer base connector board.
We also face this one also.
Clear?
These vaporizers. That's
Yes, clear.
Okay. So here the machine trigger AG airway occluded after ventilation, replace a new sampling line, water trap, sample gas return tube. All these is not solving the problem. Okay. All this is not. So they replaced the accessories of the AG module, and still they are getting the same error or the same problem, which is AG airway occluded. Finally, they find the cause of that. The main reason is that the sampling line return was not connected properly in the sampling line return connector, as seen in this video.
Okay, let's have a look.
You are hearing the sound?
Right on the internal AG model is on around 400.
Yes, we are hearing.
So everything connect correctly.
Trigger alarm.
Is connected correctly. Okay, some users they feel the resistance here when they push the CPC connector inside. They push in this position. Okay, it looks connected well, right? Pump is 0, and there's alarm AG airway occluded. If this occluded continues, during the next AG mode 0, it will trigger another alarm. AG 0 fail. So that's the problem here. So what we need to remind users is we need to close this connector until you hear the click voice from this locker. Okay. Now it's connected very well, and let's have a look. And the alarm is also disappeared.
Clear?
Yeah, that's clear.
Yes, clear.
Okay. Yes. And here we have this case I faced by myself. Auto manual leakage test fail. Okay, and the leakage was more than 200 milliliter per minute. Sometimes it passed when trying to find the leakage point. So we went through the leakage, the possible leakage point, like the AG module sample gas return. Okay, first time it passed, second time it passed, third time it failed again. We opened the back door and we sealed the sampling line return tube, the inner one, and it passed. Again it failed. Okay, we went through all the things, all the possible leakage points, like we changed the canister, or we check the bypass valve as well. We check we don't have oxygen sensor installed, so no need to check the oxygen sensor or in. So we did everything to check if there is actual leakage. After that, when we were asking the customer to perform the flow sensor calculation, they say already done. But when we did the constant flow test, okay, we were sitting like 10 minutes and we find clear difference between the expiration flow sensor and the internal flow sensor, okay, which was more than 1 liter per minute. For example, 10 liter per minute, it will be detected here at 12 or 13. Okay, so after we did the calibration of the flow sensor, it passed, and the problem solved. We checked many times again, and there was no leakage at all. When we export the log, we find that the loss calibration hasn't been performed before. It's only one time when we did it. Okay, clear?
Clear. Can be. That's why you.
Yeah. Okay. Here another HJ, leakage test and expiration valve valve calibration failed.
Oh, see the
Okay.
membranes.
We try to find the root cause, link shortage tube directly from inspiration to expiration. Still, we have a leakage of more than 200 ml.
What's the cause of that?
Okay. Perform diagnosis
Leakage,
test to identify the leakage point.
Leakage test,
According to the
expiration
test,
valve.
we can see the expiration valve. The expiration valve seal cannot be closed properly.
Ito yung ano,
Why? Because we are setting 50
yung vaporizer.
and the maximum
Yung
reach open here is
canister.
45.
CO2?
So it's not closed properly.
Durog yung ano niya CO2 yun. Durog.
However, if we change the PEEP to 80, the flow can be passed inspiration and expiration way, and the measurement will be okay. Okay, after we try to calibrate the expiration valve, it gives fail. Trying to disassemble and reposition the valve, result pass. However, system still fail. The leakage test still fail. Okay. Finally, we find out that the soda lime there is accumulation of soda lime in the canister. They didn't change the soda lime in the frequent period of time, so which lead to the hardness of the soda lime in the soda lime boundaries, okay, or in the soda lime canister, which block the way from inspiration to expiration, which lead to this problem. Is this clear?
Yeah.
Yeah, it's very
Yes,
clear.
Every month bang palitan ng ano? Soda lime. Hindi no?
It depends. Sometimes every 6 hours they have to change the soda lime. It depends on the usage of the device.
Every 6 hours?
It depends on the surgery and on the concentration and on the entitled CO2 of that patient. But usually the color of the soda lime will change from the.
There is a changes of color, engineer. Once we will, the user is so the lime is discolored, that time they will replace, or maybe 1 month or 2 months like that. It depends.
No, too long. 2 months. Maybe it's too long. Sometimes for the long surgery, they are changing the soda lime during the surgery. Okay, this is case sharing again. The anesthesia machine during software upgrade shows power fail, and after the trying the package, the device fail on
They say they're depending on surgery. The
HFNC
long
or
surgery,
AOS
6
upgrade
hour
and
fail.
other. The anesthesia machine shows message, main board reset. Okay. The process of upgrade is important to have a good AC line regulated during the upgrade. If the power port step during the upgrade fail, it will need to be replaced the DC-DC port on the anesthesia machine due to the package file for the power port is not allowed. Okay, so the package, there is no package file for the power port only. So it's included with the other package as in package.
So need to upgrade every time. So then
Okay, so if you encounter this problem, now we have the package port for the power port only. Okay, so in case if you have this problem, you can install the power port package as a standalone power port package. It became like package, not M package. M package means multiple package. It's for this module and other module as well. Okay, so and also you have to make sure if the HFNC and OAS while you are doing the upgrade fail, you have to make sure, as mentioned before, to turn on the HFNC or the auxiliary air oxygen button, to turn it on, and then try to do upgrade again.
Okay.
But if you are still getting the main board reset, this is because you have to install the power board package again. Is this clear?
Yes, great.
Before we cannot install the power board package only because it was included in the multiple package. So there is no separate software for the power board only. Okay, but now we have the power board package as well. So once you have this problem, you can reinstall the power board package. instead of replacing the DTC port.
No, it should be here also. There is also.
Okay. Okay, here received from Australia, the vaporizer output reading was inaccurate and vaporizer self-test failure. Suspect the vaporizer was malfunction. From the log, there is no record about the inaccurate vaporizer output, but there is vaporizer calibration failure. And the vaporizer calibration depends on the drive gas pressure and the vaporizer itself. From the log, there is no record of inaccurate vaporizer output, but there is a vaporizer calibration failure. For the vaporizer, calibrate the original vaporizer or another A9. What's the calibration that can be done in the vaporizer? It's only the injector calibration. Okay, so they try to make the vaporizer calibration with the software higher 1.16 to double check if the original vaporizer worked fine. If the vaporizer failed, replace the vaporizer. So if you encounter such a problem, you will just make sure that the software version of the device is more than 1.16. Okay. Otherwise, you have only to check the drive gas pressure. If it's within the range of 150, from 140 to 160 is fine. Okay. And if you find that the software is more than 1.16 and the drive gas pressure is within the range, then the main cause is the vaporizer itself. You just replace the complete vaporizer. Here.
Why this A7 is different than A8 or A9?
Okay.
How is it?
So here we have also internal AG module errors due to.
How is it? A7.
Sorry?
Engineer, I have a question. Can I interchange the vaporizer, the electronic vaporizer of A9 to another unit?
Sorry?
Can I interchange the vaporizer? Say, for example, sevoflurane. I can interchange the one to the other unit. There is no issue.
But you have to confirm that these two units are within the same software version.
Oh, okay.
Then you
Okay.
Okay.
Should we upgrade the software? No?
I thought it cannot be interchanged.
Okay, received also internal AG module error 02, print failure. After analyzing the whole part, the R&D
No, you should check the software version.
There were anesthetic droplet in the airflow ejected from the V90. The droplet entered the built-in gas module and were damaged by the internal AG, causing this alarm. So this is the worst scenario that I'm talking about for the internal AG module. If there is some droplet from the anesthetic agent going inside the internal AG module, it might cause defective to the internal AG module. But firstly, we have to confirm also the software version to be more than 1.16. I see almost all the software more than 1.16 will not have this problem. Okay, unless if there is another cause of this issue. Okay. Because this version after 1.16 they have added the flushing function to internal AG and reduced the AG flow internal AG flow error frequency. This software has been replaced, and also you can replace the new ACGO assembly because they changed the design of the new ACGO assembly, and the connector of the internal AG module port, it became in the upper side, so less contamination of the AG of the anesthetic agent goes to the internal AG module. So there is some improvement of replacing the internal or of replacing the ACGO, because the sample gas which going to the internal AG module, it became in the other side now, and there is less chance of contamination of the AG of an anesthetic agent to the internal AG module. But anyway, if you are getting
What
this
aging
error,
is?
first step you have to
Anesthetic gas.
do upgrade of the
Acidic?
software to
Anesthetic
make sure
gas.
that your software is more than 1.6.
Anesthetic gas means all.
Huh? Gas module.
Okay. A9, the abnormal tidal volume display caused by defective three-way stop cock is suspecting during use of okay. The customer thinks
He
that the
said
fault
10 to 4 o'clock now is going to pass.
threaten patient safety and define the event as an adverse event. Okay, the three-way stop cock fail resulting the abnormal measurement. The failure of three-way stop cock is caused by supplier process change. Okay, this is for before we have the three-way valve supported by ASCO company. Okay, and now we are having the new three-way valve assembly provided by Barker company. Okay, so if you have a problem with the zeroing, and also when we are exporting the log, we will have a lot of zero fail. We are expecting that maybe you have the old three-way valve, so we are recommended to change the three-way valve to the new one made by Barker company. Or else we are suspecting also there is a problem of your software if your machine is very old and your software is less than 1.50. So your first step, you have to upgrade the software. We highly recommend to upgrade all the software to the latest version. And then we suspect there is a problem with the three-way valve assembly that caused the leakage also. Or maybe it's not actual leakage, similar case we have encountered. It's not actual leakage, but since the zeroing point is inaccurate, so the machine will detect it as a leakage. Clear?
Clear.
Suppose you are going to change this vaporizer, new one.
Okay.
So after that, after replacing this one, you have to upgrade the software or no need?
No need.
No need.
Also, this is the software causing a problem of the patient circuit leak. Currently, we are encountering this problem as well in the in Qatar. Okay, we have patient circuit leak, but it's not actual leakage actually. So the problem is for the old device, very old device, if it's below software of 1.15, you have to upgrade it to the newer software to solve this leakage problem. Okay, here we have system check failure. A9 always failed during system check, although replacing with the new briefing circuit already, but still we have problem with the system check failure. System check used silicon briefing tube, cross-check with other briefing circuit to justify the leakage. It comes from circuit or from the main unit. Standby mode, manual mode, ABL 250. Okay, so after doing all these tests, still we have a system leakage test fail. Okay, like auto or manual leakage test fail. Okay, here we have the manual. We have the auto and copiers and manual circuit leakage test fail. So what they did? They just put the machine to stand by the manual mode and they adjust the ABL 250. Okay, and lock the back arm. Press auto flash until the pressure reach to 30 centimeters and ensure the pressure keeps stable. Result the pressure drop quickly and leakage is from inside the main unit. Okay. Reason they found the tube from the ACGO to the briefing connector was loose. After connecting this tube, the problem has been solved.
Okay.
Okay. Vaporizer duct failure. 3-unit A9 get vaporizer duct failure for new unit. System check vaporizer test sometime passed and sometime fail. Mostly passed. Electronic vaporizer test. Pneumatic lock test pass. Drive gas pressure pass. Analyze the electric diagram and check the cable. Then find the root cause. This cable which connected to the vaporizer base connector is loose. So this vaporizer duct failure problem. If you have this problem, most probably the cable which connected to the vaporizer connector board is loose.
If not,
Sorry? That's all for the case sharing and for the training as well.
That's
for the
No, it's good. Narinig tayo pa. Hindi hindi tayo narinig. Ilan tayo narinig.
how do you listen?
So this is the current quality plan that we have.
If the
All of you guys aware about this quality plan that we have in the A8, A9?
Quality plan.
just fill this form.
So this quality plan is to solve the historical problem of the A809. So the phenomenon that we have is O2 nitrous oxide leakage due to sealing ring in the cylinder yoke. Okay, and poor plug of electronic vaporizer cause anesthetic leakage. O2 leakage test fail because of the expiration valve membrane is too hard. Expiration valve calibration fail, and the manual leakage test fail because of manual bag is too soft. So what's the solution? O2 nitrous oxide leakage due to sealing ring of cylinder yoke. Replace the sealing ring of the cylinder yoke. Okay, poor plug of electronic vaporizer causes anesthetic leakage. Replace the plug of the vaporizer. And third one, O2 leakage test fail because of expiration valve membrane is too hard. Replace the expiration valve. Okay, and then we have the manual leakage test fail because of the manual bag is too soft. Upgrade the software to 1.20. So this quality plan considers all these four parts. Is it clear?
Customer service department services.
Okay, that's all for the training today. Do you have any question?
Pangit din pala yung malambot.
Do you have any question regarding this?
No, thank you.
Thank you, Dr.
You're welcome.
Thank you.
Thank you very
much.
You're welcome.
Can you share this presentation on the video with all, please?
Yes, for sure. I will share it with the CS, and you can get it from your concerned CS for sure.
Okay, thank you.
You are welcome.
Thank you very much.
75158.
Thank you,
Thank you
engineer.
for attendance, guys. Have a great day. Thank you. You're welcome.
Thank you very much, sir.
Thank you.
Thank you,
Have a nice day.
You're welcome. You're welcome.
Bye-bye.
Bye-bye.
Okay. So may I have your contact number, please? Oh, take the number, contact number.
I need
Contact
money
number.
for that. I have this one.
You have already?
Yeah, he gave me this one.
Oh.
This is the
From Egypt?
No, he's Jordanian.
Jordan. Urdan. In Arabic, Urdan. English, Jordan.
Paano po i-approve tong ano mo dyan? Wala akong...
Khalas, you have...
Dito lang sa ano? Pwede ko na i-approve sa email.
Khalas, I will stop my recording. Thank you guys. See you. Have a nice day. Bye bye.